Okay, na. So for this session, no, last time we were able to discuss chemical safety and hopefully nakagawa na kayo ng prob set doon, no. So ang isa sa mga na-share kong reflection ko sa students ko last time, no. Sa kabilang section ko siya na-share eh. When it comes to chemical safety, no, naalala nyo yung pyramid, no. So doon sa pyramid na yon, nasa lower portion yung PPE, no? And nasa higher portion yung elimination, basically administrative control, no? So isn't that relevant sa nangyayari sa atin ngayon, no? Kasi we are always expected, no, to wear PPE. Yes, we do that naman. However, hindi pa rin mawawala yung pandemic, no? As long as the administrative control is not done. Okay? Hanggat walang ginagawa yung administration, walang mangyayari sa atin, no? Kasi according to the hierarchy of hazard control, lower portion yung PPE, di ba? Ibig sabihin, yes, important siya, pero least effective yun, no? So if you want to really control the pandemic, then you have to have a good governance, no? You have to have a good administrative control, no? Yun yung kwento ng ng hierarchy of hazard control, no. So I haven't read all of your submissions yet, no. Pero if merong mga tao na ganun yung reflections, no, and that's very good, no. You analyze the materials very well, no. Okay, I read some of your paper na nag-cite sila ng examples, no. Yung iba naman is the uh, collection lang ng knowledge na natutunan na. Pero hopefully, ang gusto ko sa students is ma-relate yung mga nangyayari sa paligid natin, no? Okay? So, if you share the same thought as I did, no? Good yun, no? Kasi that's very relatable in our environment today. Okay? And so, puro PPE nga tayo, wala naman nangyayari sa administrative control. Wala din. Okay? So, nonsense. Kaya 400 days na tayo naka-lockdown dahil doon. Okay. But still, wear your PPE because that's the basic hazard control. Yet, basic lang yun. Okay. So, hindi pa yun dapat di yun yung last resort natin. Okay. So, anyway, so moving on with the chapter 2. So, in the chapter 2, this is a very lengthy chapter, no? Because in this chapter, we will discuss energies, no? And I don't know if pero karamihan sa inyo siguro hindi STEM major, no? So ibig sabihin nun, hindi kayo siguro nakapag-thermodynamics nun. Kasi kapag STEM kayo, no, madidiscuss yung thermodynamics doon. Okay? So since most of you ay hindi STEM, no? So we will try to cover, no, the basics muna. Kaya ang first session ko is the review of Gen Chem before we go into the main topic talaga na. Okay? So hopefully this session will help you review the lessons learned last semester, no? And how to apply it, no, sa thermodynamics, no? So introductory course pa lang tayo. Okay? So basic pa lang to. Okay? So this is the chapter outline. We will try to cover all of them today. Madali lang naman siya actually, especially the first two. Okay? Dimension analysis, this is just conversions, no? Chemical relationship and stoichiometry, or chemical reactions and stoichiometry, this is very easy. Alam nyo na yan, no? Pero discuss pa rin natin, no? Kasi baka mamaya nakalimutan na, no? Okay? So after this, we will start discussing about energy na. Okay? So yan. And this will continue until May 8, no? So medyo matagal-tagal to. Okay? So let's start na para marami tayong time. Okay. So in your Gen Chem, ang first topic doon is the measurement, no? So what is measurement according to Gen Chem, no? Last semester na-discuss dapat to, no? So pag sinabing measurement, ito lang yung way mo to to quantify the observable, no? Okay? So, kunwari nakita mo, uy, mahaba, no? Gaano siya kahaba? Okay. O kaya na-feel mo, uy, parang ang bigat nitong object na 'to, gaano 'to kabigat, no? Okay? So, measurement is one way to ano, to quantify the observable, no? Yung na-observe mo sa mga physical objects, no? Pwede mo yung ma-quantify. When you say quantify, mabibilang mo or mame-measure mo. Okay? So, ito yung isa pang definition ng measurement, yung isa yung Tagalog version. Ito yung English version. It is the extent, the size, the capacity, or the amount of something that has been determined. No? Basically, this is the quantification of observable. No? Kunwari, nakita mo from here to PUP, sobrang layo. O gaano kalayo? Measurement yung sasagot ng tanong na yun. No? Kunwari, ikaw, um, nag-diet ka last time, tapos feel mo magaan ka na. Gano'n na ako kagaan, or gano'n na ako kabigat, no? Okay. So, kumbaga, the measurement will answer the question, gaano? Gaano karami? Gaano kabigat, no? Okay? So, gaano katagal, no? So, yun yung mga ina-answer ng measurement, no? Because they try to quantify the observables, no? And measurements are composed of two components, no? So, may dalawa siyang component. You have the magnitude and the unit, no? So, when we say magnitude, this is the numerical value, no? Sinasabi niya, ito yung nagsasabi, gaano, okay? Kunwari, 5, 10, no? Pero yung unit, it makes sense, this thing, no, makes sense of the magnitude, no? Okay? Kaya nga mapapansin niyo nung high school tayo, 'di ba? Pag walang unit yung sagot natin, ano sasabihin ng teacher niyo? Ano 'tong 10 na 'to? 10 carabaos, no? 10 horses, hindi, no? 10 grams, no? So, bakit, no? Kasi the magnitude will not matter, no? Without units, okay? So, number lang kasi ito, no? So, may measuring scale lang tayo that tells us the magnitude. But, the unit will make sense kung ano yung number na yon. Kunwari, 300. Ano yung 300 na yon? Carabaos, 300 pesos, 300 moles, no? Okay? So, ibig sabihin, kailangan partner itong dalawa. Hindi lang pwede number meron ka, no? Other than the number, you should have the units, no? And speaking of units, no, we have developed, no, a huge variety of units in the entirety of human history, no. Yung units ng measurement that started with the imperial units, no. If you could remember your Gen Chem well, okay. So the imperial units, ano yon? That is a way of measuring something based on the ruler's proportions, no? Kunwari, ako yung hari ng Egypt, okay? Tas ganito kahaba yung paa ko. Siyempre, di ko mapapakita ko sa inyo pa ako ngayon, no? Ayun, kunwari, ako yung hari ng Egypt, tas sabi ko, ito yung aking isang paa. I will call it 1 feet, 1 foot, okay? Okay, and I will start measuring distances using my paa, okay? So, kaya tayo nagkaroon ng 5 foot, okay? 1 feet, nalito na ako sa plural at singular. Basta yan. Yun yung dahilan bakit meron tayo mga 5 feet, 6 feet, no? 12 feet, no? Dahil yun sa literal na paa, no? So, literal na paa kasi mini-measure nun. And that's a product of the imperial history, no? Imperial measurement history. Okay? Kunwari, ako naman, ako pa rin, hari ng Egypt ako. I will measure objects using my dipa, no? So that's the distance of this middle finger to the other side pag in-extend ko yung arms ko. Okay? Kunwari, ito isang dipan to. Tapos another dip pa. Okay? And so on and so forth na. So I can measure distances using my arm span or the dipa, 'di ba? Okay. Kunwari, itong bahay na to, 10 dipa ito. Okay. Ibig sabihin 10 times na mag-e-extend ako ng kamay ko, no? And that is equal to the length of the house, no? So yun yung basic roots ng measurement, no? So parang sa imperial system, they base the sizes, no, they based everything in their ruler's body proportion, no. Kaya nga may literal tayo na feet, no, measurement. Meron tayong mga dipa, dangkal, no. Even sa Filipino, ganun din naman, di ba? Isang dangkal, 5 dangkal. Yun yung mga imperial units of measurements, okay? Ang 1 inch nga, isang thumb, di ba? Okay? Di ba? So, mga body sizes yung pinapatukuyan natin doon. However, as science progresses, no, it seeks a better way of measurement, no. So, after some years, no, when I say some years, hundreds of years, no, or thousands of years, no, yung imperial system natin, that was replaced by what's called the English system, no, or the English system. Ano yun? O, yun na yung mga gumagamit ng mga meters, miles, no? Okay? So, they try now to remove the humans sa measurements, no? Bakit? Kasi yung human sizes, iba-iba yun eh. Okay? Ako, maliit akong tao. Ganito lang yung dipa ko. Tapos may isang tao, mas malaki siya. Mas mahaba yung dipa niya. So, dun nagkakaroon ng problem before, no? Kasi yung size ng isang tao is different with the other. Okay? So, kumbaga, kung sa kanya, 5 na dipa yun, tapos sa'yo, 7 na dipa yun, sino yung nagsasabi ng totoo? Di ba? Okay. So, parang yun yung naging problem with the imperial system. No? Iba-iba yung magiging numbers depending on sino yung basis ng measurement. No? Kunwari, iba-iba yung hari. Namatay ako, tapos pinalitan ako ng ako uli. No? Kunwari, nabuhay uli ako, tapos ako yung naging bagong hari. No? Okay. So, yan. Iba-iba yung body size ko. Iba-iba yung body size ng mga hari. No? And as a result, iba-iba yung forms ng measurement. No? So, yan. Yung puro yun. Ayun. So, habang nag-i-improve na yung paligid, no? Nag-start na tayo matuto maging kapitalista. Okay? So, kailangan may formal way tayo to measure things, no? Kasi when we are trading our goods with the other kingdoms, pwede magkaroon ng problema, no? Magkamali ka lang ng measurement, giyera na dati 'yun, no? Okay? So that's why in France, no, they developed this English system, no, in France and British, no. So yun, sila yung mga nagtulungan to develop the British system, which removed the human factor in the measurement, no. So instead of measuring objects using humans, no, they use observable sa Earth, no. Kunwari, someone measured the distance from the North Pole to the equator, dinivide niya yun by a certain number, then you get a meter. Okay? So, yun. And someone, use the rotation of the sun, okay? And dinivide niya yung by certain number to get the seconds. Okay? So, yun. Doon na nag-start ma-formalize yung ating way of measurement, no? So, in measuring time, may na-develop na tayong, dati sundial lang no? Yung mga stick na tinutusok mo lang sa lupa, tas depending on the angle, ma-measure mo yung oras, no? But using sand sand clocks, no? Pwede mo na ma-measure yung time precisely in seconds, no? Okay? So, maraming na-develop dun, no? And I'm not really aware of the specific stories for each measurement na. Kasi that was way back, 17th century or 16th century. Okay? So, marami nangyari, no? Marami silang, mineasure, dinivide na numbers, minultiply, no? Okay? And then they arrive with the English system, no? Okay? So, yun. And then, after nun, no? Nung nag-start na mag-boom yung science, no, in the early 19th century, we tried, no, to make better measurements, no, that removes variable objects sa paligid natin. Okay? So, tinanggal na natin yung mga physical objects talaga. Rather, we defined the measurements, no, in units that are constant. of the universe, no? And dun na na-develop yung SI system natin. Okay? So the SI system is an internationally agreed units of measurement that is not based on physical objects. Rather, they are based on universal constants. Okay? So universal constants to. And this is ginamitan niya ng physics, of course, no? Okay? So, we have 7 base units for the SI unit or the System International, the unites. Okay? So, yan. So, we have 7 base units. We have the second, meter, kilogram, ampere, Kelvin, mole, and candela. Okay? Okay. So, before, meron na yung versions, no? Pero, this is the, universally accepted units, no? Para kunwari mapunta ka sa Mars, no? Magtayo ka ng kingdom mo doon. You can still use this, no? Kasi these numbers, no, hindi lang to applicable sa Earth, no? This can be applied to other universes as well. Kasi nga universal constants na yung ginagamit niya dito. Okay? So for example, the second that is based on the oscillation of cesium-133 atoms. If it creates this 9 billion something oscillations, that's equal to a second, no? Kunwari, kapag meter naman, that is the fraction of the distance of traveled by light, okay? Basically, light second, no? So, ang travel ng light in this fraction is a meter, okay? Pag kilogram naman, before this was based on a prototype, no? Yung steel ball na nasa France until now. However, that's a physical object. So they tried to remove the physical factor sa measurement, no? So they redefined, no? This is the newest redefinition of the measurement. So in kilogram, that is now defined based on the Planck's constant, no? Planck's constant is an energy constant we use in physics, no? Okay, so yun. That is an energy constant. When you set a constant to a certain number, then you can get the kilogram, no, corresponding mass niya. Okay, so ganun yung ginawa nila. Phoenix na nila yung Planck's constant, so they will get the kilogram. No? Ano ba yung meaning ng kilogram? Using energy conversions. O kapag ampere naman, it has something to do with the flow of this number of electrons or the elementary charge. No? Pag Kelvin naman, this is the that is also related with the Boltzmann constant. No? That's the energy over the temperature. No? And pag mole naman, this one was attributed to Avogadro. Sabi niya, if we have a mole of a substance, then we have this huge number of particles. No? And that is also backed by science. O hindi lang hula-hula yung number na yan, may basis yan, which is yung charged particles din, mga elementary particles. Minultiply, divide niya yun, and nakuha niya yung number na yan. Ang candela naman, this is something to do with the light intensity. Okay? And it was based on the frequency of light then. Parang sa second lang din. Okay? So yan. So instead of using physical objects, they now use the universal constants in defining our measurements, no? Why there is a need, no, to define these measurements in terms of universal constant, no? Una sa lahat, we are at the verge of being interplanetary species, no? Malapit na tayo maging interplanetary species, no? Maybe in the near future nasa Mars na tayo, no? I don't know because the Earth is dying. Okay? So ibig sabihin nun, dapat ang measurements natin should apply everywhere you go, no? Pumunta ka man sa moon, pumunta ka man sa Mars, pumunta ka man sa Andromeda Galaxy, no? So, ibig sabihin, dapat yung measurements na nagagamit mo can be used in other universes as well, di ba? Okay. So, ganun. Yun yung reason. Isang reason. Pangalawa is for standardizing trade, no? especially kapag tayo ay nasa stock market, no? So ako, nag-i-invest ako dati sa stock market, kaso natakot lang ako slightly kasi alam mo naman yung political climate ng Pilipinas, magulo, nakaka-apekto yun sa stocks, no? Minsan naaangat yung value mo, tapos mamaya bukas negative ka na, no? Ayun, lugi ka pa. So, pinull out ko yung pera ko dun. Okay. So, important yun sa stocks. Bakit, no? Kasi every second matters, no? For, for trading. Okay. So, every seconds, nagma-matter yun. So, dapat ma-define very well yun. Second. O, kunwari naman, nagtitinda ka. Okay? So, kailangan maganda yung definition mo ng kilogram. Hindi pwede yung bubuhatin mo lang. Tapos sabi mo, eto 5 kilograms to, bilhin mo na. Okay? Kailangan may set kang uh, proper way of measuring a kilogram of an object, di ba? Okay? So, yun lang, no? So, basically, ang kwento ko sa inyo is the evolution of the units, di ba? So, we started measuring our body sizes, no? Sa imperial system. Then, yung body sizes natin, na-convert yon into, into mga physically observable objects sa Earth, no? Okay, so from humans, naging Earth na yung basis ng measurement natin. The rotation of the Earth, nakuha yung second doon. Okay, the distance of Earth, North Pole to equator, doon nakuha yung definition ng meter, so on so forth na. And then now, due to improvements in science, na redefine natin lahat, removing all the physical factors, no? Constants na yung ginamit natin. Okay? So, yan, no? So, ang daming nangyari, no? Yes, ganun talaga, no? And, yan. Okay? So, yun lang yung kwento nun. Nakwento na naman yun nandyan, kaya nag-share lang uli ako. Okay. So, anyway. So, the SI units, mapapansin nyo, 7 lang sila, pero we use a lot, no? Okay. Kasi we can derive other units, no, using the SI units, no. For example, if you want to get the volume, then all you have to do is to just cube the meter, no. Okay? 3 times mo lang yung length, you will get the volume, no. Length with height yan. Okay? And the formal definition of a meter is the cube of the length, no, or the cube of the meter. Okay? Other physical quantity that can be derived from the SI unit is the force. Okay, the unit is newtons, no? In honor of kilala nyo na si Newton. Okay, so yan. So force is defined as the mass of an object divided by the mass of an object divided by length times the second squared, no? Okay. So, yan. Kunwari, energy naman, that is attributed to Joule, no? Kasi siya yung, parang naging father of thermochem, no? Si Joule. Okay. And that was defined as the force times the length, no? Okay. And so on, so forth, no? So, marami na tayong nakuhang other quantities, no? From this, no? Kunwari, ito, i-divide mo to dito. Kilogram, meter, tapos divide mo uli yan by 2 second, no? Second square, no? You get the force, no? Okay. Kunwari, ito, i-divide mo to dito, pati dito, tapos ito, doblehin mo. You will get the energy na. Okay? O, kunwari, ito, you divide the kilogram by the mole, or the grams divided by mole, you will get the molar mass, no? Okay? So, by dividing all this, no, you can get other units, no? Okay? Yun yung kagandahan ng SI unit, no? So, divide mo lang sila, may makukuhang kang new quantities, no? Okay? And these are some of them. Another good thing with the SI unit, no, is that it can be expanded, no? Okay? So, before kasi, kunwari, ikaw, sailor ka, hindi, di ka na lang sailor. Kunwari, nag-ano ka na lang, ikaw yung tagapadala ng sulat before, no? Ikaw yung parang mailman before, o ikaw yung taga-Lazada dati, no? Nung early 16th century. Pag naglalakad sila, bibilangin talaga nila. Ayan, isang feet, so on and so forth na. Kunwari, they are reporting distance from one point to other. Sasabihin nila, 500,000 feet. No? Ang laking number. No? What if mas mahaba yung distance? 1,372,355 feet, no? Sobrang layo, sobrang daming numbers, no? Yun yung nagiging problem pag sobrang daming numbers na. Okay, lalo na kung maraming zero, no? Kasi ang problem is that manual kasi dati, no? So when you write zeros, kailangan di ka talaga magkamali because removal of one zero, ibig sabihin nun, reduce na yung value mo by a factor of 10, no? So, yung 1 million, iba na yun sa 100,000, no? So, 10 times yung, nawala na. Okay, so to remove the errors, no, in writing zeros before, no? Kasi manual pa talaga dati. So, isusulat mo talaga lahat ng zero kung kinakailangan. So, to remove that factor, ang inintroduce nila together with the SI system are the Greek prefixes. No? So, the Greek prefixes will remove of the extra zeros by multiplying them by these numbers. No? Kunwari, you have, let's say, um, 0.0000005 meter. Okay? Kunwari, you have 0.00005 meter. You can redefine this na. Pwede mo yan i-redefine as ilan? Bilangin mo lang daw yung 0. 1, 2, 3, 4, 5, 6. No? So, parang 5 times 10 raised to negative 6 meter yan. Pili tayo dito. Okay? So, that number can be written as 5 micrometers na lang. Okay? So instead of writing all those zeros, we can just write this, no? Okay, nawala yung mga zero, no? But we introduce a prefix to the unit, no? We introduce a prefix to the unit. No? So yun yung kagandahan sa SI system, expandable siya. Okay? Ibig sabihin nun, kapag marami ka ng zero, pwede mo sila tanggalin by just attaching the prefixes, no? Kunwari, ikaw, naglalakad ka. Ang meters na na-measure mo is 1,500,000. Ayan. Ayan. So, yan. 1,500,000 meters. Okay? So, itong 1,500,000 meters, you can abbreviate this as, 1, 2, 3, 4, 5, 6, 1.5 megameters, no? Okay? So, ibig sabihin, nawawala na yung errors pagdating sa zero. No? Kasi yung mga scientists before, sulat-sulat sila ng zero. Sa sobrang dami ng zero, pwede magkamali. No? So, yun yung naitulong ng Greek prefixes sa SI units. No? So, pwede mo sila i-attach when describing big or small numbers. No? Okay? So, less prone ka sa error. No? Kasi, papansin nyo, di ba, wala namang kilo feet, no? Decifeet, centifeet, 'di ba? Walang ganun. Kasi hindi pa alam tong system na to sa imperial system, pati sa sa imperial system. Wala pang ganun eh. Okay. Pero sa introduction ng SI units and sa English system, ayun, lumabas na yung mga prefixes, no. So ano yung purpose nila? To allow us to shorten the numbers, no? To shorten the magnitude of our measurements, no? Para less prone sa error. Okay? And ito pa yung so ito yung summary ng lahat ng measurements. Mapapansin nyo, hindi na tayo nagda-dive into deep details kasi nga review lang naman to. Okay? So ito yung ito yung pinaka-summary talaga ng lahat ng measurements natin, no? So you still have this the 7 base unit in the SI followed by the other usable units natin sa thermodynamics, no. So kapag SI unit, ito yung mga kanilang units, no. If you follow the metric system which is a precursor of the SI system, ito yung ginagamit. CGS or the centimeter gram second system. Ayan yung ginagamit. English system. Ito yung luma. Ayan. Okay. So, yan. So, ito yung mga gagamitin natin. Okay. So, skip lang tayo kasi lang naman tayo. Review lang, ha? Ang mahalaga na trace back natin yung history ng measurement. No? So, nag-umpisa tayo sa pagme-measure ng paa. Ngayon, nagme-measure na tayo ng distance ng light. No? Galing na. So, in just 100-year span, ang daming nangyari sa science. Okay? So, ito yung naging problem ngayon. Ang papansin nyo, ang daming units na. No? May units in miles, merong units in meter, merong units in pounds, merong units in gram. So paano yung mga paano yung mga nagte-trade dati? Paano yung mga scientists before? Okay? Kasi naman pag nag-introduce ka ng measurement system, hindi lahat susunod diyan agad-agad. Take for example the United States of America. Until now, they do not follow the the metric system, no? Hindi nila fina-follow 'to. Ang ginagamit pa rin nila is the old one, no? They use the imperial system pa. Okay? So, ang gagawin mo doon is kapag may ayaw gumamit ng metric system or the SI unit, i-convert mo yung units. Okay? So, doon na papasok yung main topic natin, no? Dimension analysis, no? Para magkaunawaan pa rin kayo, no? Okay? So, conversion of units is necessary. Okay? So that yung measurements ng other people, other scientists in the other parts of the world can be translated to your measurement system, no? Okay? So kunwari may American nag-measure, this is 5 miles, no? Pwede mo ma-convert sa isip mo, 5 miles is 5 times 1.6, no? Kilometers, no? Ayun. So pwede mo ma-convert yung units na. Okay? So, yun yung yun lang yung naging problem kasi sobrang dami ng units na na-introduce sa paligid natin. So, as a result, we need conversions, no? And in these tables, no? Tables kasi marami sila. So, dito sa tables natin na to, makikita natin yung corresponding conversion of one unit to another. Huwag nyo to kakabisaduhin, okay? Kasi ayaw kong nagkakabisado kayo. Lang, just save this file. Okay, so we can use this to convert one unit to the other unit. Okay, for example, you have a kilogram, you want to convert that into pounds, no? That means that's just 2.2, no? Times 2.2 mo lang. Or you have a mile, convert that to kilometer, 1.6, no? Okay, kunwari, you have a gallon, you want to convert into liters. Ayan, there are corresponding conversions, no? And again, bakit nagkaroon ng conversion? Because of the the many units na nasa paligid na natin. Super dami na ng units natin sa paligid eh. Okay? So, it is necessary for us to convert one unit to the other so that magkakaunawaan pa rin tayo. Ano pa? May nangyaring accident before sa United States, no? Sa NASA, no? That's actually a Mars satellite, Mars Reconnaissance Orbiter ata yun. Let me Google it, no? Para ma-share ko rin sa inyo. Orbiter failure. Okay. So, bakit naging important lalo ang conversions? Because of this case, no? So, let me share you this one. Okay. So, this was an incident that really triggered, no, the push, no, to unify the measurements sa paligid natin. So, this is the Mars Climate Orbiter. Okay. So, this is a very expensive orbiter, no? It costs about billions of dollars. However, because of not converting units properly, nawala siya, nasira siya sa atmosphere ng Mars, no? So when this orbiter, no, when this satellite is approaching the gravitational field of the Mars, ang nangyari, hindi enough yung energy na produce ng engine niya to circularize its orbit, no? So instead na maging circle yung orbit niya, nag-plummet siya towards the surface of the Mars, no? Okay. Ano yung naging problem dyan? Ang naging problem is the conversion factor lang. And the cause of failure is just the conversion factor. Kaya kung babasahin niyo yan. So ito yung naging ito yung naging push talaga dati, no, to unify all the measurement systems na. Okay, recent lang yan, no? 1 year old na ako niyan, 1999 yan eh. Okay. So yan. So ito yung naging push for them to unify all the measurements sa paligid natin, no. Okay. So yan. Diyan natin makikita yung importance kasi isang maling conversion lang $1 billion ang pwedeng maging epekto. Okay? And syempre, engineers kayo. Okay, kunwari magkamali kayo ng conversion ng force ng concrete, no? Yung force na kaya ng concrete, no? Ang nakuha nyo is pounds, tas ang kailangan ay joules, no? I mean newtons, no? So magkaibang value 'yon, no? Kunwari ni-report nyo 5 newtons yung kaya ng 5 newtons yung kaya ng concrete na to. Tas ginawa mo, hindi mo siya kinonvert to pounds, no? Pwede masira agad yung concrete mo, no? Pwede masira building mo. Makukulong ka pa, no? Okay? So it is very important in the field of STEM, no? Especially in engineering, to convert the units very carefully. Okay? So yan, take note of these conversion factors. Okay? So para mag-push na tayo sa ating recitation, ngayon let me kickstart the solving process. Okay? So I will start with the first one, okay? And then I will let you answer the two, okay? So ito sasagutan ko to, then kayo sagot kayo nito. So paano tayo magre-recite? I will accept the first 5 answers, no? First 5 answers for number 2 and number 3. So pwede na kayo mag-start, no? Pero magsasagot pa ako. Okay. O, kunwari, ito. Let's try to convert 24.8 British thermal units or BTU. British thermal units yan. Okay. So let's try to convert 24.8 BTU, British thermal units, into calories, no? So, paano yon? Okay. So, paano yon? Gagawin nyo? So, in converting one unit to the other, you should know the conversion factors, no? So, ang gagawin mo, gawa ka ng process. From BTU, kailangan maging calories yan. Okay? So, anong conversion factors ang kakailanganin natin? Tingin na lang kayo sa copy nyo ng material. Okay? Dito yun. Energy yung BTU eh. So, to convert BTU to to calories, okay? Mapansin nyo that 1 joule is equal to this BTU and 1 joule is also equal to this calorie. So that means this BTU is equal to this calorie, di ba? Okay? So sulat natin 'yon dito. Marunong na kayo dapat mag-convert review lang to. Okay? So according to the table, 1 joule is equal to 9.47 831 times 10 raised to negative 4 British thermal units. Okay. And also 1 joule is equal to 0.239006 calories. No? So since etong dalawa ay equal, that means etong dalawa ay equal din. Okay. So we can say the conversion factor we can use is 0.239006 calorie is equal to 9.47831 times 10 raised to negative 4 BTU. So we can use this conversion factor to convert this BTU into calories. Let's do that, no? So ano yung format ng dimension analysis? The format is you have a given unit and then you multiply it by your conversion factor. and you will get your desired unit, no? So typically, the conversion factor is a fraction, okay? That is a fraction wherein your given unit is in the bottom so that they will get canceled, okay? And your desired unit is on the numerator, no? Ito yung desired. So this is a fraction. Paano na-establish yung fraction na yan? Dito, sa conversion table natin. Okay? So dito mo makukuha yung ilalagay mo dito sa conversion factor. 'Di ba? Ganyan ginagawa ninyo ng Gen Chem. So this must not be new for you. Okay? So let's follow that format. So we have 24.8 British thermal units. And let's multiply it by a fraction or the conversion factor. Since we want to cancel the BTU, we should place the BTU at the bottom. Okay. So ito yung BTU natin. Lagay natin siya sa baba. 9.47831 times 10 raised to negative 4 BTU. Okay. Yung BTU gusto mo makancel. So kailangan nasa baba siya. And yung calorie, ito yung desired unit ko. Okay? So that means nasa taas dapat siya. 0.239.006 calories. Okay? So by canceling them, matanggal na yung BTU. Ang natira ay calories. Let's multiply them. Okay? So I have my calculator here para alam nyo kung ano mga pinagpipindot ko sa buhay. Okay? So pindutin natin yan. 24.8 times the conversion factor. That's 0.239006 divided by 9.47831 times 10 raised to negative 4. So this is the conversion of British thermal units to calories. No? 24.8 BTU is equivalent to 6253.59 calories. Okay? So, yan yung energy natin. Okay? So, again, this must not be new to you. Bakit? Kasi Gen Chem pa lang, nagko-convert na tayo. Okay? Marami naman sa inyong pumasa nung Gen Chem, no? Tataas grades nyo. So, I assume, no, that you all know the conversion. Pero again, binabalikan natin sila para walang sisihan. Okay? So, yan. Kasi sa Thermodynamics, super daming conversion mangyayari sa atin. As in, super dami. Okay? So, very important na ma-recall natin to. Okay? So, that is the answer. You should get the, you should get that, ha? How about the other two, no? Sa number 2, I will be accepting 5 answers, no? Post your answer na lang dito sa chat box. Okay? With solution ba? Yes, with solution. With solution. Huwag niyo i-copy-paste yung sagot ng may solution. Okay? Ang mag-copy-paste ng sagot ng may solution, hindi magkakajowa. Okay, so the first 5 lang yung tatanggapin natin. Okay, and they will get 1 point each. Saan ko ilalagay yung points na yan sa sa quiz, no? Okay, kasi medyo maraming nadudali sa quiz talaga eh. Medyo marami, kaya okay lang. Okay. Okay, so let's have the other answers. Okay lang, may solution ha. Dapat pala naka-PM sa akin, no, para hindi ko makikita, para hindi niyo makikita answers. Pwede yun sa Zoom eh. Yung sa Zoom pwede ka mag-chat na siya lang makakabasa. Pero sa Teams walang ganun. Okay. Mahirap pala mag-recitation dito. Sa Zoom, madali lang eh. Kasi pwede ka mag-send to sa akin lang. Check ko nga. MS Teams. Dalawa na yung nagsagot. Wala talaga, no? Okay na yan, no? So, medyo may technical difficulty tayo sa kasi nakikita niyo yung answer ng iba. Pero Pero ayun. Okay. So, tignan natin ano yung correct answer. Let me show you. So, we are going to convert calories into Joule. Ba't ko binura? Ba't ko binala yung conversion? Okay. So, anyway, the conversion is that 1 Joule is equal to 0.23906 calories, di ba? Okay? So, ito yung conversion talaga. So, if we have 1.4 times 10 raised to negative 5 calories, you multiply it by the conversion factor. Nasa baba yung calories, 239,006 calories. Nasa numerator ang joule. Bakit nasa baba? Kasi gusto mo sila mag-cancel out. Okay? Pindutin ko yan sa calcu natin. Pindot tayo sa calcu. So, that's 1.4 times 10 raised to negative 5 multiplied by the fraction 1 joule, 0.239006. Enter. Ang sagot ay pindutin ng SD. Ayan. Ay, negative 5 ba? Positive 5 pala, sorry. Positive 5 pala to, sorry. Ayan, positive 5. Kala ko negative eh. Buruhin ko lang yung negative doon. That's positive. Ayan. So this is the answer. 5857 759.35 joule. Okay. Yung first 5 lang titignan ko ha. So we have, ilalike ko na lang kapag may points kayo. Okay. 1, 2, 3, 4, 5. Ayan na. Sorry, Angelo Ay, nagsagot na rin siya sa 3 advance na. Ilalike ko na lang yan. Nagsagot ka sa 3. Okay. So, yan. Okay. So, yan. May sagot na siya sa 2. So, ganun lang na. Yun. For number 3, sige, first 5 uli. So, meron na si Angelo. Papansin nyo, no, hindi ko pinapapicturean yung solution nyo. Kasi, di ko alam kung naka-cellphone kayo ngayon or naka-laptop eh. Okay. Pero there is a question later na I need picture sa solution. May question mamaya na kailangan ko ng solution. Credit natin yung points nyo para transparent tayo. Ano ngayon? 24 April. Okay, so we have Dadia 1 point, Honorubia 1 point, Abuyo 1 point, Villarreal 1 point, One, two, three, four. Si Henry class. May copy naman kayo ng PowerPoint. So, yan. For number 3, so the first na nag-answer si Angelo, followed by Lovely, Rika. Okay, so like ko yung mga nauna. Ayan. Tignan natin kung tama sila. We also have Honey again. Next meeting, I will try to improve this recitation process. Akala ko may parang Zoom feature to eh. 'Di ba sa Zoom, pwede ka mag-send ng message sa isang tao lang. Pero apparently sa Teams wala pala. No? Okay. So improve ko yan next meeting. Don't worry. Okay. Ayan. So sa ngayon, ganito muna tayo ha. Parang joke time lang, no? Ayan. Okay, so hanggang kay MacBry lang yung natanggap natin. So let's check if your answers are correct. So we are asked to convert. Remove natin. 51.6 millijoule to BTU. Okay. MJ is millijoules. No? Okay, milli. Ang tanong, what is milli? Okay. A milli is 1,000 of a joule. Okay? Sabi natin, 1 joule is 10 raised to negative 3. I mean, 1 millijoule. Sabi sa Greek prefixes kanina, 1 millijoule is 10 raised to negative 3 of the base unit. And also, kita nyo sa table kanina that 1 joule is equal to 9.47831 times 10 raised to negative 4 BTU. Okay, so we need multiple conversion factors now for this problem. Okay, so yung gagawin nyo, yung MJ, palitan mo ng joule. Okay, yun muna gagawin mo. Kasi you cannot convert MJ to BTU eh, no? So millijoule muna i-convert mo. Okay. Then once you have the joule, convert that to BTU, the British Thermal Units. You will encounter that pag pag sa MECeng pala yun. Akala ko civil nga pala kaya, no? Okay, so I don't know kung saan nyo ito ma-encounter, pero sa MECeng na-encounter nila to sa RAC nila. I mean sa HVAC. Okay, dun yan. Ayan, so yan yung ating calculation. Pindutin ang calcu. Asan yung calcu ko? Wala. Tabunan na. Ayan. Ito calcu. We have 51.6 times the conversion factor. 10 times ano na lang. 10 raised to negative 3 times 9.47831 times 10 raised to negative 4. Ala, ba't nandun yun? Ayan, dito pala, sorry. 9.47831 times 10 raised to negative 4. Ayan. Okay. So, this is the answer. May tumama ba? Tignan natin. Ang ginawa nyo, yung BTU, ba't siya naging 947? Ba't siya naging 947? Wait lang ha. Wait lang. Pero that's our answer. May nagdo-doorbell lang. Wait lang po. And sorry. Anyway, saan kayo nadali? Nadali kayo sa BTU. Okay. Ang BTU ay times 10 raised to negative 4, ha? Okay. Ayan o, mag-ingat-ingat. So, okay. So, mali. Or maybe I will accept si Dadia. Okay. I will accept the answer na lang. Okay. Yan. That's 4.89 times 10 raised to negative 5 BTU. Okay? San kayo nadali dito? Kasi ito times 10 raised to negative 4 eh. Kung ito, nilagay nyo to dito, that will still not be equal to 947. Okay, so yan. Ayan ha, be careful ha. Okay. So yan. So this is the proper way of converting one unit to the other. Take note na lang, screenshot nyo yan para may reference kayo. 4.89 times 10 raised to negative 5 British thermal units. Ayan, bigyan ko lang ng points si Dacia. Ayan, 2 points na. Ayan. Don't worry, marami pa tayong titiisin mamayang mga problem. But this one, carry out the conversion. Nasa ano ba kayo? May cellphone ba kayo with you? No? Ayan. Anyway, wala lang. Sige, manually type the answer na lang. No? Pero wag kayo magkopyahan. Okay. Wala tayo sa MS. Wala tayo sa Zoom eh. Okay. So, in converting one temperature unit to the other, may ginagamit tayong conversions na. Ano 'yon? Ito. So, when converting Celsius to Fahrenheit and vice versa, ito yung gagamitin nating equation. Nandito yan eh. Ayan. Ayan yung equation na gagamitin natin. So, kopyahin natin dun sa kabila. So, that's degrees Celsius equals 5/9 degrees Fahrenheit minus 32. Yan. Yung parenthesis kulang. Ayan. So that is the conversion of Celsius to Fahrenheit. Okay? So from this you can actually derive kung paano naman yung Fahrenheit Celsius to Fahrenheit, no. So from this we can convert we can convert the two. Kunwari yung degrees F gusto mo kunin, gagawin mo you cross multiply the 9, cross multiply mo yung 9 pati yung 5 cross multiply lang. So you get 9/5 degrees Celsius equals to degrees Fahrenheit minus 32. Okay, so add 32 on both sides. You will get degrees Fahrenheit equals 9/5 degrees Celsius plus 32. Kailangan matuto kayo mag-derive ha. Okay, matatanda na tayo, derive din. Okay, and when when converting Kelvin to Celsius, Celsius to Kelvin. When converting Celsius to Kelvin, all you have to do is to add 273.15. Okay. So Kelvin is equal to degrees Celsius plus 273.15. Okay. Ang unit ng 273.15 ay Kelvin per degree Celsius. No? Ayan. Pero kahit wag mo na isulat yun. Bakit? Kasi 1-to-1 lang naman yung ratio nila. Okay. So, yan. So, ito yung mga tatlong conversions na gagamitin natin. Okay. Ayan. Try to answer number 1. First 5 na magsagot sa 1, consider ko. First 5 dito sa 1. Okay, lalike ko yung heart na lang kasi ibang problem na to. Okay, so 1, 2, 3, 4, 5. Okay. So, number 2 naman. Nakuha ko na yung first 5 answers sa 1 eh. Number 2 naman. Number 2, we have si Macpray, nilagay na lahat. Sige. Ayan na. 3, 4, 5. Let's have number 3. Type your answers. Number 3. Paunahan na lang. Number 3, start tayo kay Fritz Gerald. 1, 2, 3. Okay, 4. And 5. Wait lang. Gumagalaw-galaw. Si Angelo, wait lang. Basahin ko sabi ni Angelo. May nasend siya sa taas. Ngayon. Nilagay mo na pala lahat dito. Sige na, consider natin yan. 3. Paano yung 3? Ayan, nag-type na sila sa 3. Okay. 1, 2. Ay, teka lang. Anong number na ba? 1, 2. I think 4 na tayo. No? 4 na. Okay. So, for 4. 4. Ayan. Yung mga points, ibigay ko na lang after the class na like ko naman yung mga pasok sa top 5 eh. Last one sa number 4. Okay, tapos na tayo sa 4. About number 5. Number 5 na tayo. So, that starts with Ruel. Ang hirap pala mag-monitor dito. Nakakaloka. 2, 3, 4. Isa na lang. Yan, okay. Tapos na. Okay. Sa iba, don't worry, meron pa mamaya. Yung next na sasagutan nyo is naman, may solving na, no? So, habang nagsosolve ako dito, kuha na kayo ng calculator, kuha na kayo ng papel, notebook, tapos comment nyo na yung picture naman, okay? So, ganun mangyayari sa atin. Okay. So, pero habang kumukuha kayo ng mga resources na yon, cellphone camera din, picturean nyo, tapos upload nyo na lang. Pag walang pang picture, naka-webcam ba kayo? May webcam kayo, honey? Pwede naman sa webcam. O kaya, pwede i-type nyo sa i-type nyo sa Word yung answer. Okay. Pwede naman, type sa Word. Kunwari, ganito. Medyo matatagalan nga lang kayo. Okay. Kunwari, yan? Type mo equation. Ayan na. Okay. Although mas matagal dito kaysa sa sulat ka. Pero yun, pwede nyo naman i-picture using webcam, no? Okay. So, pwede naman picture using webcam. Mababaliktad nga lang ata. Okay. Okay, so yan na, mag-prepare muna kayo ng mga gagamitin for the next batch of recitation. Sa ngayon, magsasolve muna ako ng answers dito. Okay, so we have this one muna. Okay, so sa number 1, that's Fahrenheit to Celsius, no? So when converting Fahrenheit to Celsius, that is degrees Celsius equals 5/9 degrees Fahrenheit minus 32. Okay? So, ayan. Plug in na lang basically, no? So, for 1, that's degrees Celsius, 5/9, 72 minus 32. Dito na lang sa calcu ko dito. 5/9 into minus 32. Mag-ready na kayo ng ano ha, for the next batch ng recitation. This is 22.22 degrees Celsius. Ito naman, baliktad, Celsius to Fahrenheit. So that's basically degrees Fahrenheit equals 9/5 degrees Celsius plus 32. That's 9/5 to 16 plus 32. That's 420. Okay. Next one, we have Celsius to Kelvin. Basically, add to 73.15. Important ba yung 0.15? Yes, for me, that's very important. Okay. Pero I will accept answer kahit di naka 0.15. 315 Kelvin to Celsius. Ito. Gagawin nyo dyan from Kelvin, gagawin mong degrees Celsius, then gagawin mong Fahrenheit, no? So, Kelvin to Celsius, just subtract to 73.15. Okay. That's 315 minus 273.15. That's just 41.85. Mainit pala yan, no? Okay. Then from Celsius, gawin mo Fahrenheit, that's 9/5, 9/5, 41.85 plus 32. 9/5 plus 32. That's 107.33 Fahrenheit, sorry. One 107.33 Fahrenheit. Then lastly, for number 5, 0K to Fahrenheit. Okay. 0 Kelvin, gagawin mong Fahrenheit. Ano yan? Ay, ba't ko binura lahat? 22.2. Kailangan ko eraser lang eh. Ito, 420.8. Tama ba naaalala ko? 506. Tapos ito ay sagot natin dito, 107. Basta yung 107 na lang. Ito, 0K to Fahrenheit. No? So, gawin mo yung Kelvin to Celsius to Fahrenheit. So, Celsius is 273.15 plus 0 degrees. Ay, sorry. Wait lang. Baliktad. Celsius nga pala hinahanap. So, that is Kelvin minus 273.15. So, this is negative 273.15 degrees Celsius. Okay. Then, yung degrees Celsius, convert mo siya to Fahrenheit. Okay. So, convert mo to Fahrenheit. That is, degree Fahrenheit equals 5/9 degrees Celsius plus 32. Negative 133.97 Fahrenheit. Negative 130. Let me double check. Let me double check. So, Kelvin to Celsius, negative 273.15 yan. Okay. So, Celsius na to. That's 5/9 times this plus 32. And, yeah, 133.97. Tignan ko lang tama yung formula ko, ha? Ayan. Nabura ko yung nakasulat kanina eh. And, oo nga pala. Teka lang, derive ako, wait lang. Nawala ko yung derive ko kanina, kaya di ko alam kung tama yung na-type ko dyan. So, 9/5 Celsius. 9/5. Okay. Cancel. Maging minus yan. Ito pala. Sorry. Okay, sorry. Mali to. Mali. Ayan. Madalas mangyari sa akin yung nabubura ko yung nasusulat ko sa board eh. Okay. Okay, so that's 273.15 degrees Celsius minus 32. Ayun, lumabas na yung answer. Negative 523.67. Ayan na. Sorry kanina. Nabura ko yung sagot eh. Nabura ko yung derivation ko kaya nalito ako. Okay? So, ayan. So, these are the answers. No? We have 22.2, 420.8, 506, 107, negative 523. Okay? So, ayan. Ayan. Try natin yung walang 0.15 kasi yung iba sa inyo hindi naglagay ng 0.15 eh. Let us try that. No? Try natin kapag walang 0.15, 9/5, negative 273, minus 32. Ay, wait lang guys, sorry. Naduling na talaga ako dahil nabura ko yung solution ko kanina. This is negative pala, sorry. Ayun, nakakita ko na. Minus dapat to. So, it should be plus here. Oops. Ayan. Sorry, nawala. 0.15 plus 32 pala, sorry. Ayun. Okay. So, this is not the correct answer. This is the correct answer. Yan. Pag nawala yung 0.15, it should be negative 459. Ayan. Ayan. Ano yung lesson learned? Huwag burahin yung dinerive. Nalito tuloy ako ng grabe. Ayan. Hindi ko nabuburahin yung nakasulat doon. Okay, so these are the answer. 22, 420, 506, 107, negative 459. Ayun. Ayan. Okay, so good. Bigyan ko na ng points yung mga nasama ko, ha. Okay, so mag-prepare muna kayo ng gagamitin natin for the next batch ng recitation. Okay? So, Honorubia. Saan na yan? Yan. Dadya. Isidro. Abuyo 1. Yares. Labanan. Tanya, nakakuha na kayo ng ng notebook, picture. Pwede rin naman mag-type sa sa Word na. Ayan. Nasaan na ako? Honorubia uli. Nag-iipon kayo ng points, ha? Actually, ngayon lang ako nagpa-recitation sa class ko. Kasi kapag face-to-face, di talaga ako nagpapa-recite, eh. Ano lang, kawang gawa lang. Parang thank you, nag-recite ka. Ayan. Kasi sa akin, okay lang kahit matulog sila. So, number 3, 506. So, tumama. Isidro. Ayan, Isidro. Si Neil. Ayan. Datcha. Ano nangyari sa chat? Ayan. Number 4, sino yung mga tumama? O kung nagugutom kayo, pwede kayo kumain habang nagka-class tayo. Pero mukhang G kayo sa recitation, eh. Okay. Ayan. So, number 4, 107 Fahrenheit. Honorubia uli. Dami yun ng points. Tapos mamaya, lagpas score nyo, no? Edi okay yun, no? Lagpas. Wait lang. Tama ba? Ayan. Infante. Dadya. Abuyo. Ayan. Yung points dito, pwede rin to makredit sa mga nyo, kasi same lang yung weight ng quiz pati prob set, eh. Okay. So yung prob sets ninyo, ayun, mababa prob set nyo, pwede dun ko na lang ilagay yung points nyo. Okay. Group score plus yung recitation points. Pwede ganun na lang. Kasi same lang yung weight ng quiz pati ng same lang yung weight ng quiz pati ng prob set, eh. Kaya ganun. Ay, ano na ba? Number 5 na. Gozon, Gozon. Honorubia uli. Yan. And ayan. Okay. Next batch tayo. Ayan. Ako muna bago kayo. Okay. So, ako muna magsasolve. So, what is the density? What is the mass of air that measures this? Okay. Calculate the density. Ito yung density. I mean the density of the air is this. Calculate the mass of this room. No, the air in the room. express your answer in kilogram. Okay. So, ano to? Ano to? Ito. Ano yun? Yan ay volume. Kasi you have a unit of length cube, no? So, length, no? Length with height. So, cube yan. Okay? So, this is, cubic feet. So, kailangan ang cubic feet mo, i-convert mo siya to, meters, no? Kasi nakalagay doon, ang ating density is naka-liters, no? Actually, you can convert liters to, you can convert liters to meters then, okay? So, ganun mangyayari sa atin. Pakita ko sa inyo yung flow pag ganito. So, i-multiply mo yung A, B, and C. Okay, so A, B, and C, that will give you cubic feet, okay? Pero yung cubic feet, you need to convert this into cubic meter, okay? So, you now have a cubic meter here. As susunod, yung density mo, yung gram per ml niya, gram per liter, i-convert mo yon into kilograms per meter. Okay? Ayan. Cubic meter pala, sorry. Okay. So, you convert this grams to kilograms, liter to cubic meter. May mga conversion ba yon? Meron siya conversion. Okay? So may conversion from liters to cubic meter. I will show you later, no, kung ano yung conversion natin doon. Okay? So, yan yung ating flow. Okay? So, kung titignan mo yung problem, cubic feet to, kailangan mo gawing cubic meter yon. Bakit kailangan cubic meter? Kasi yung liter, pwede mo siya ma-convert to cubic meter, no? Yung liter, pwede ma-convert to cubic meter. Okay? Pwede mo sila i-convert ng ganun. Paano mo i-execute yan? How to execute that? Okay? So, ganito lang. Start tayo. Volume. That will be 17.5 feet times 19.5 feet times 8.50 feet. Sabayan nyo kapag nagsasolve, ha? Okay. 17.5, 19.5 times 8.5. Syntax error. Nadoble ko yung multiply. Okay, so this is equal to 2900625 cubic feet. Okay? So ngayon, we are going to convert the cubic feet volume into meters. Okay? May ganun ba sa table? May ganun ba? Kailangan maging meters to. May ganun ba? Tingin kayo dito. Mapansin nyo, sa volume, wala tayong feet to cubic meters, no? Ito meron pala, yan, no? Cubic feet to meters. Ito, kopyahin na lang natin yon. Pero, sir, what if wala, no? So, kunwari, sir, wala yan. Ang gagawin mo? Ang pwede mo gamitin is yung feet to meters. Okay? Yung feet to meters, ito yon. Yan. Tapos, i-cube mo na lang sila. Okay? I-cube mo yan, tapos i-cube mo rin to. Okay? So, pwede ganun, no? Kapag wala sa table, gawa ka paraan. Kasi, you remember, volume is saan to galing? Dito. Kinube lang to lahat, no? So, basically, pag kinube to lahat, ayun. Ang kuha mo yung volume. Okay? So, hindi porket wala dito, ibig sabihin, end of the world na, no? Hindi. Gawa ka paraan. Meron naman paraan. Okay? So, yung length, i-cube mo lang yan. So, this cube, this number, i-cube mo pa. So, you will get the proper conversion. Okay? So, hindi porket wala sa table is wala na, ha? Okay. Apparently, itong problem na to ay nasa table. Nasa table yung conversion natin. So, let me copy that dito sa slide na to. Ayan. So, nasa baba si feet. Okay? Kasi siya yung gusto mo ma-cancel. Cancel. Feet cube. Ayan. Then you have 1 cubic meter. Divide natin to by 3.3147. So we'll get 82.13. Ano na lang, 2 decimal places, no? Pag nag-quiz naman kayo, multiple choice eh. Multiple choice. Okay. Kaya okay lang mag-round off sa akin. Okay. So yan na yung volume in cubic meters. Now, ano yung ano? Ano na yung gagawin natin? Yung density mo from from grams to liters, gagawin mo siyang kilograms per cubic meter. Okay? So paano yan? So sa density, this is in units of grams per liter. Yung grams muna. Okay? So we know 1 gram, 1,000 grams, sorry. So we have 1,000 gram equals to 1 kilogram. Okay? Then followed by that is the conversion of liter to cubic meter. I think nasa PowerPoint din siya. Yes. Yeah, and andun siya. Napanaginipan ko to Oo. Alam nyo yun, yung bigla na lang, uy, napanaginipan ko to. Okay. This is 10 raised to negative 3 cubic meter. Feeling ko mag-chat sa akin kaibigan ko. Tapos alam ko na sasabihin niya sa akin. Alam niyo yun, mga ganong feeling. Convert natin to 1.19 1 over 1,000 1 over 10 raised to negative 3. Okay, so that's still 1.19. Effort pa, no? Yan. Okay, so from this, now we can say na yung gram per liter, that is just the same as kilogram per cubic meter, no? So save na lang natin yan sa isip natin. Okay, so same lang sila eh. Okay, ayan. So now we have 1.19 kilogram per cubic meter, and we have a volume of 82.14 cubic meter. Now let us solve for the mass. Okay, so what's the density formula? Gen Chem, density is mass over volume, diba? So if you're solving for mass, that's density times the volume, okay? So we have 1.19 kilogram per cubic meter times 82.14 cubic meter. So it is very necessary for you to convert the units. No? Ayan. So we get 97.75 kilograms. Ang bigat pala ng hangin, no? Okay. So yung bigat ng hangin na yan sa paligid natin, that accounts for the atmospheric pressure. Mas mabigat pa sa akin yung hangin, no? Ilang kilo lang ako 56 lang ako payat ko na. Sir, bigat pa sa akin yung hangin sa kwarto. So ayan. Okay, so yung weight ng air, yun yung reason bakit mayroon tayong atmospheric pressure. Okay.
Sir.
Yes po.
Kasama sa given yung 25 degrees Celsius.
Wait lang ha. Gamit ako ng speaker para lumakas yung audio mo.
Hello, sir.
Ano
kasama po yung given na 25 degrees Celsius. Ano pong kaugnayan ng temperature dito? Hello?
Ayan siyang factor dito. At different temperatures so the density of material change, no? Okay. So pakita ko sa inyo yung graph nun. So for water, tingin ko yung itsura. Then the density of water changes at different temperatures. Okay? So
And it is also true for other fluids, no? Like,
Sir, excuse me po, sir. Di ka po namin narinig po ng maaga.
hindi ba rin na off na muna konti. So, ito ang nangyayari. Nakakonect naman yung mic. Ang ganap kasi is, bakit may temperature doon? Ang sagot doon is because of buoyancy, no? At different temperature, the buoyancy of objects varies, no? Okay? So, ibig sabihin nun, at different temperature, yung density ng object, nagbabago. Okay? Take for example, yung ice, pati yung tubig. Bakit yung tubig, lumulutang siya sa, kapag yelo siya, pero kapag liquid siya, hindi naman siya lumulutang. Ayan. May sagot doon ay buoyancy. Yun yung sagot. Okay. Yung 25 degrees Celsius, important to. Bakit, no? Pero hindi ko susunan sa calculation. Bakit?
Sir, sorry po ulit, sir. Hanggang ngayon po, para pa rin pong kulog po yung boses po. Di pa rin po namin, sir, naintindihan po.
Let me log in ulit itong. Wait lang, ha? Ang feeling ko nalipat ng audio.
Ayan, dinig na. Ayun.
Ayun po, sir.
I'm sorry. Ayan. Nalipat yung connection ng microphone ko. Anyway, so ganito kasi nangyayari. Bakit may temperature doon? Because of buoyancy, no? According sa physics, at different temperatures, ang ating fluids will have different densities, no? That's the reason why yung water nagfo-float siya at temperatures below zero, no, as a yellow, but hindi siya nagfo-float kapag greater than zero yung ating temperature, no? And for gases, ganun din kasi fluid din yung gas, no? So iba-ibang temperature, iba-iba yung density, no? The reason lang why it is reported is that at different temperature kasi iba yung magiging value nito, okay? So hindi na siya 1.19 at different temperature, no? Parang for formality lang 'yan, no? Kasi baka mamaya makakita kayo ng ibang density. Ang sagot doon is iba kasi yung temperature na binigay, no? So i-Google natin yung density ng air at temperature. Okay? So pwede mo yung makuha actually. Ayan. So this is the graph, no? That accounts for the buoyancy of the fluid, no? Ayan. Google lang natin. Ayan. Papansin mo, at different temperatures, the density of the air varies, no? Okay. So andito tayo sa 25 degrees Celsius. So it is somewhere here. So dito yung 1.19. However, what if mas lalong uminit? The air will be less dense. Kaya nga kapag may bagyo, sinasabi nila high pressure area. Ibig sabihin nun the air is floating upwards, no? Kasi less dense na siya compared to the other air, no? So umaakit na yung hangin nun kasi mainit na masyado. So pag umakit yung hangin, lalamig siya tapos bababa siya uli. Tapos aakyat uli kapag mainit tapos bababa. So ulit-ulitin mo yung cycle na yun, bagyo na yun. Okay? So ganun yung nangyayari. So at different temperatures, yung density ng air natin ay nagbabago. Okay? So pwede siya mag-float, pwede mag-sink, pwede mag-float, pwede mag-sink, no? So etong temperature dito, ano lang siya, hindi naman siya important sa calculation, but it is vital. Kasi baka mamaya makakita kayo ng ibang temperature, tas ibang density, sabihin nyo hala sir, but sa last problem, 1.19 yan. But dito sa problem na to, 1.5. Okay, ang sagot doon, baka kasi iba yung temperature. Okay? So yun lang yung idea, no? Yung temperature, sasabihin yan to state the density, na. Okay? So, interrelated sila because of buoyancy sa physics, na. Okay? Madidiscuss naman yung buoyancy pag madidiscuss yung buoyancy sa inyo kapag nag-physics 4N na kayo. Which is, I think, next sem, no? Ayan. So, yan. Nabura yung answer ulit, no? Anyway, let's proceed with the next one. Ito, ako uli magsasagot ng first part. Tapos kayo na bahala sa pagtuloy, okay? Bibigyan ko kayo ng kickstart dito. Basahin natin, a dead weight gauge, no? Ay, wala. Ano ito napindot ko? Yan. Okay, so a dead weight gauge with a 1 centimeter diameter piston and a mass of 6.14 kilograms bring into a balance. No? What is the gauge pressure being measured? If the barometric pressure is 748 torr, what's the absolute pressure? Okay. So, ano yung dead weight gauge? No? Yung dead weight gauge ay ganito lang. So, para siyang cylinder. No? Ayan. Ayan. Para siyang ano, isang hollow tube tas isang solid na cylinder. No? Nakapatong yan, nakaganon siya sa loob. No? So, andito yung gas sa loob. No? So, kapag yung gas nag-expand, yung takip aakyat. Okay? Pag yung gas nag-contract, bababa yung takip. No? And we use the dead weight gauge, no, to determine the pressures of gases. No? Kunwari, may chemical reaction ka. Yung gas nun, ilagay mo dito. Okay. So, kunwari, kunwari, itong chemical reaction dito, nag-produce siya ng gases, aangat yan. Okay. So, with the height change, no, pwede mo makuha yung, pressure ng ating, close ko yan. Okay. So, pwede mo makuha yung pressure ng ating chemical reaction. Pressure ng gas sa chemical reaction. Okay? So, ganun lang yung idea dyan. Okay? So, ngayon, paano nakukuha yung pressure? No? So, the pressure in physics is the force over the area, di ba? So, that is the force exerted by an object or gas, no? So that is the force exerted by an object over a portion of an area. No? Okay, and we know in physics that force is equals to mass times the acceleration. Okay, so yan. So ganun lang ginagawa namin. No? So yan. You can determine the pressure by accounting for the force and divide mo yan sa area. No. Okay. So force ng yun yung force ng takip. Okay. So yun yung force ng takip. That's the force of the takip, no? That is the mass of the takip times the A. Okay. So ano yung A? The acceleration due to gravity because vertical yung displacement dito. Okay. So ang acceleration that we have to account for that is the gravitational pull kasi naka-vertical axis yung change natin. Pag horizontal axis yung change natin, that is edi yung typical acceleration, no? Change in x over time, no? Twice mo yun, acceleration yun. Okay. Pero since vertical yung changes natin, then the acceleration is equal to the gravitational acceleration. Okay? So, yun. So, dun. Pag pinag-multiply mo yung mass neto times the gravitational pull, that's the force, no? The area is yung size ng area sa ilalim. Remember, this is cylinder. So, ano yung shape ng nasa ilalim? Circle. Kasi cylinder nga di ba? So, circle yung nasa ilalim. And we know that the area of the circle is equal to pi r square. Okay? So, we can substitute the values. So, we have the mass of the takip, no, times the gravitational acceleration, which is 9.8 meters per second square. Okay? And you divide that by the area, which is pi r square. Okay? O, yung mass ng gauge is given as this, no? The gravitational pull is 9.8 meter per second square. Yung constant yan. So, kailangan alam na natin yan. And the radius, hindi binigay yung radius, no? Binigay diameter, no? But you can get the radius from this, no? Okay. Ano yung relationship ng diameter and radius? 2r lang. Okay? So, plug in all those info, you will get the pressure exerted by the gas here. Pag sinabi namang absolute pressure, ibang calculation naman yan. Pag sinabi kasi naming absolute pressure, ito na yung total pressure, no? Ipag-add mo na lahat ng pressures na accounted sa setup na to. So, ano yung mga pressures na involved sa setup natin? the pressure of the gauge. Ayan, spelling na naman. Kopyahin ko na lang spelling doon. Mali-mali eh. Gauge plus the pressure of the barometer, no? Pag sinabing absolute pressure, lahat na yon ng pressure i-add mo na. Given naman yon parate, yung ibang pressure. Ang isosolve mo lang talaga is the pressure of the gauge, no? Okay? So, ganun lang. Okay, so I want you to solve for the pressure of the gauge. Ito na yung equation. Force over area, mass times acceleration over area. In our setup, that's mass times the gravitational pull because the change is in the vertical axis, no? And the area is is the area of the cylinder, the base of the cylinder, which is a circle. And we know that the area of the circle is pi r square. Since diameter binigay, convert that to radius, no? Then you will get the pressure of the gauge. Then solve for the absolute pressure by adding the barometric pressure and the gauge pressure. Ipagpa-plus mo lang sila. Okay? So, yan. Ano pa yung mga important units dito? Ano pa yung mga important units? Ang mga important units dito is that the force is in newtons, no? Okay? So 1 newton is 1 kilogram per meter seconds. I mean kilogram meter per second square, sorry. Kilogram meter per second square, that's 1 newton. Okay. Ano pa? Ang area mo dapat dito should be in meters, okay? The area should be in meters, no? And the pressure is tingin na nga tayo dito. Sa table, di ko kabisado yung table eh. Hindi naman kasi dapat kabisaduhin yan. Okay. So 1 newton is kilogram meter per second square. Ayan. Okay. So yun. Tapos yung area, dapat naka-meters yan. Okay? So yan. So ano magiging final unit mo niyan? Kung yung numerator ay Newton, Newton sa numerator, then you have the meter square sa baba. What's that? That is Pascal. Okay? That is Pascal. 1 Pascal. 1 Pascal is Newton per meter square. Okay? So, ayan. So, ibig sabihin yung unit of pressure mo dito is Pascal. What if, ano to sir? Naka-torr to eh. Okay. So, gagawin mo dyan, i-convert mo na naman yung Pascal to another unit, no? So, co-convert mo na naman yan, no? Yung Pascal, convert that to other units. Ano yung conversion nila? 1 ATM equals 101.325 Pascal. That's also equal to 760 torr. Okay. Pwede mo yun i-convert. Okay. So, itong Pascal na masosolve mo, convert mo to torr. Okay. Then, saka mo siya pwede i-add dito. Okay. Pero ano by the way, since medyo alas 12 na pala, nawalan ako ng hindi ko napansin yung oras. Okay, so since medyo mahaba tong calculation na to, maybe ano na lang to. Maybe I will add this na lang sa group assignment natin. Pasensya na ha. Nawalan ako ng tingin sa oras. Alas 12 na pala. Kala ko 11 pa lang eh. So this will be assigned to you as group assignment na lang yan. Na? So again, just follow the method. Na? So yan. So the pressure can be obtained by dividing the force exerted by the cylinder over the area at the bottom of it. No? Force is mass times acceleration, newtons per law of motion yan. Okay? And since vertical yung displacement sa piston, A is the gravitation constant. No? And yung area, pi r square yan. Kasi square yung ilalim. I mean circle yung ilalim. Okay? Pag nakuha mo itong P na to, makukuha mo dun is the Pascal unit, no? That's the Newton per meter square. Then, torr yung kasama niya. So, para mapag-add mo sila, dapat same unit sila. So, itong pressure ng gauge from Pascal, you convert that to torr. I gave you these two conversion factors. Then, saka mo sila ipag-add. Then, you will get the absolute pressure. Ano na lang to ha, group assignment kasi medyo mahaba na. Tsaka, nawalan ako ng tingin sa time. Mag-aalas 12:30 na pala. Same as this one. No? Group assignment na lang din to. Pag-usapan nyo na lang yan ulit sa group na. So, ibig sabihin, pasahan pa niyan is March 8. No? March 8 pa na. Ay, May 8. No? April na pala. So, May 8 yan. Okay. Ito naman, about this, paano nyo to sasagutan? Okay, so what is mercury? Mercury is liquid, no? Liquid yan at room temperature. At 27 degrees liquid ang mercury. So, ibig sabihin, kung tinatanong yung pressure niyan, then you should use the equation for the pressure of the liquid, no? According to physics, the pressure of the liquid is rho GH, no? Or density yung rho, okay? Let me rewrite it. No? Erase ko lang. For liquids, the pressure is density gravitational pull times the height. Okay? So density, given yan. Ito yan. Ayan. That's the density of the liquid. Gravitational pull, sinabi na, 9.8 meters square meter per second square. Then the height is in centimeter. Okay? So yan. Rho GH yan, or the density grams times height. Make sure that the units will cancel. Okay? Kailangan ang makuha nyo dito is Newton per meter square. Okay? So find a way to get this final unit, no? Yung Newton per meter square. Find a way paano mo ma-convert yung units na to this. Okay? So, medyo related yan dito. Just follow the conversions I showed you. And then, after that, convert that into units of bar, no? Apat kasi yan eh. You have the Pascal, you have the ATM, you have the bar, you have the torr, no? And you have the mmHg. Okay? So, look for the value of the bar na lang, no? The bar. Alak lang, no? Okay, so find for the value of this na lang. Okay, so nasa, I think nandun yan sa table. Okay, so group assignment na lang yan together with this one. So plus 2 yung ating assignment. So May 8 pa yan, May 8. Okay, matagal pa. Pero sagutan nyo na ngayon pa lang. Okay, para masanay. Tapos pag-usapan nyo yun sa group kaya tayo meron channel. Okay, pwede kayo dun mag-usap, pwede kayo dun mag-meet, no? Doon na lang kayo mag-vid call na mga kaklase mo. Okay? Para makapag group review kayo. Okay? Now, let's proceed, no? Nagtagalan tayo sa calculation. Anyway, so let's proceed. Chemical reaction, no? And stoichiometry. This is very necessary in this subject. Bakit? This is chemistry, no? Chemistry, ibig sabihin, may chemicals, no? And when we are dealing with chemicals, we know that they react with each other. Okay? Generally speaking, these are the types of the chemical reaction. You have the acid-base, precipitation, reduction, oxidation, and combustion reaction. When acid-base reaction is, ang pinag-uusapan, that is just the reaction between hydronium ion and hydroxide ions to produce water. This is also called the neutralization reaction. Okay? When we say precipitation reaction naman, we are forming precipitates, no? So, important dito yung solubility rules. Okay? Na-discuss ba to sa inyo? I don't know, no? Pero kung na-discuss to, edi good na. Okay. So, important yung solubility rules dyan. Redox reaction, di-discuss uli natin to sa electrochem, no? So, skip yan. And then, to be discussed in electrochem yan. Then we have the combustion reaction, which is the reaction of fuel to energy. Okay. Okay. So, ganun. So, sa Chem 4eng, ang primary focus talaga natin is this one. Okay. So, ito yung primary focus natin. The combustion reaction. Bakit, no? Kasi bilang engineers, no? Bilang kayo, mga future engineers, you want to harness energy, no? O, kunwari, gagawa kayo ng nuclear power plant, no? Basically, that's the reaction of the fuel, the uranium, to energy, no? Kuryente. Okay. No, kunwari, may sasakyan ka, you have the gasolina, no? Ko-convert mo yan into energy to push the car, no? Okay? So, yun yung focus natin sa Chem 4eng, not the others, no? Okay? So, ibig sabihin, let's talk about combustion reaction in particular. Okay? So, familiar na tayo dito when we say combustion reaction. That's the reaction of your material with oxygen to produce carbon dioxide and water. Okay? So, this is the general equation. You have the fuel plus O2 producing CO2 and H2O. The question maybe is, ano yung fuel? Okay. So, the fuel ay any material, no, na combustible. Generally speaking, these are organic matter. Okay. Such as paper, wood, no? Okay. Gasoline, hydrocarbons, no? So, those molecules are organic matter which can serve as the fuel, no? Okay. Pag nagpapagasolina kayo, fuel tawag doon, di ba? Nangyayari doon is that when it is when it is inside the engine na, sinusunog yon, no? In the presence of oxygen. Sinusunog yung gasolina para umandar yung sasakyan, no? Para gumalaw-galaw yung piston. Okay? And as a result, andar na yung car natin. Okay? So, yan. So, this is the combustion equation. And you should know how to balance this, no? Kailangan marunong kayo mag-balance. Paano nga ba mag-balance ng combustion reaction? Madali lang, no? Ito yung priority mo sa pag-balance ng combustion reaction. The C, H, and O. Step by step to. You balance the carbon first, then you balance the hydrogen, then you balance the oxygen lastly. Okay? So, hopefully, naalala nyo to kasi na-discuss to sa Gen Chem. Pero discuss ko pa rin, no? Okay. So, this is glucose, no? C6H12O6. If I combust it in oxygen, we will get carbon dioxide and water. But as you can see, the number of atoms are not the same. So that means violation to ng law of conservation of mass or the law of conservation of energy. Hindi pwede na kulang-kulang yung atoms mo. That means we have to balance the equation. Yun yung dahilan ba't kailangan natin mag-balance, the law of conservation of mass. No? Hindi sabi niya doon, hindi pwede kulang-kulang. No? Dapat kung ilan yung mass mo dito, ganun din sa kabila. Okay? Okay. Pag atoms ang pinag-usapan, kung ilang atoms mo dito, ganun din dapat sa kabila. Okay? So, in balancing combustion reaction, ito yung pattern. Balance the C, balance the H, then lastly, balance the oxygen. Balance natin yung C. On the reactant side, you have 6. On the product side, isa lang. So, in order to balance it, huwag kayo maggaganon. No? Huwag nyo ilalagay yung 6 dyan. Mali yan. Okay? Anong gagawin nyo? You introduce a coefficient. No? You multiply the entire equation by 6. No? Entire formula rather. So, you multiply this by 6. No? Hindi ka pwede magbago ng subscript. Masama yun. No? Magagalit ako nun. No? Magwawala ako pag naglagay kayo ng subscript dyan. So, kailangan coefficient lang, ha? Okay. Pag nakita ko may subscript dyan na nagbago, no? Gigil nyo ako. Okay. So, kung 6 to, dapat 6 yung coefficient doon. Ito. Tapos na yung carbon. Sunod is hydrogen. So, 12 yung hydrogen natin dito sa kabila. 2 lang. Again, wag mo lalagyan ng 1 doon. Magwawala ako. Okay. So, ano gagawin nyo para mabalance yung hydrogen? Di times 6 mo yan, no? Para maging 6 times 12, 12. Okay. So, you have 12 hydrogens here, 12 hydrogens there. Okay? So, balance na yung carbon, balance na yung hydrogen, lastly, oxygen. Pag oxygen naman, yung right side na yung bilangin mo kasi balance na yung carbon and hydrogen dito eh. So, bilangin mo na lang kung ilan yung oxygen dito. Okay, ilan nga ba? You have 6 times 2. 6 times 2 is 12. 6 times 1 is 6. That's ilan? 18. Okay, so on the right side, you have 18 oxygens. On the left side, kailangan 18 din. Kailangan 18 din para maging balance. Okay, so yung 18 na yan, yung ilan doon nandito sa glucose, yung ilan nandito dapat. Okay. O ilan nasa glucose? 6 na, no? Pwede mo ba baguhin to? Wag na. Wag mo na baguhin yan kasi balance na yan, no? Kasi pag binago mo to, kunwari nilagay mo yun ng 3, wala na, magbabago na naman to. Pinahirapan mo lang sarili mo. Okay. So, kung ilan yung oxygen dito, tanggapin mo na lang siya. Okay. So, ibig sabihin, ang kailangan mo baguhin ay ito. Itong oxygen sa kabila. Kasi siya yung walang coefficient pa. Okay. So, again, bilangin mo yung ilang oxygen meron sa kanan, then ganun din dapat sa kaliwa. Then yung 18 oxygens na to, it could be here or there, no? And there, no? So, yun, meron siya dito, meron din doon. Ito, wag mo babaguhin. Bakit? Kasi nga, balance na yung carbon and hydrogen, no? Wala ka nang gagawin dito, ha? Ito yung papakilaman mo na. So, yung 6 nandito, so ilan dapat dito? 12. Okay? Kasi 6 plus 12 is 18. Ito, may 2 na doon. So, paano magiging 12 to? Times 6 mo lang yan. Okay? So, you now have a balanced equation. So, ganun lang, di ba? Madali lang, naalala pa siguro yan, no? Carbons muna, hydrogens muna, then bilangin oxygen sa kanan, then saka i-balance yung oxygen sa kaliwa. Okay? Hopefully, naalala pa. Okay, mataas naman kayo sa Gen Chem eh. Ayan. Kasi ako, naalala ko, sa Gen Chem ko, may mga nakados pa sa akin last sem. Meron pa nga 2.5. Okay. So, ganun. Medyo mahigpit kasi ako sa Gen Chem talaga. Ito naman. Ito. Let's balance this. This is sucrose. Okay. So, this is sucrose. Combusted. Ito yung asukal natin. I-combust mo siya. Ano yung magiging balance equation? Balance the carbon. 12 yan. Isa to. So, lagay mo 12. Okay. So, napalaki yung 12. So, 12 carbons. Okay, balance na. Hydrogens, 22. Ito, 11. Ito, 2. So, kailangan mo ng 11 na coefficient. So, 12 CO2, 11 H2O. Ano problema? Ang problema, hindi balance yung oxygen. Okay? So, bilangin mo ilan na oxygen ko sa kabila. So, what is 12 times 2? 24. What's 11 times 1? 11. So, ilan to? 35 oxygens. So, kung 35 yung oxygen doon, kailangan sa kabila 35 oxygens din. So, kailangan 35 din dito sa kabila. Okay? So, yan. Then, ito ang 35 oxygen na to, dapat meron dito and meron doon. O, yung 11 dyan, dito na. So, ilan dapat sa kabila? Edi 24. Okay? Babaguhin mo ba to? Hindi na. Wag mo babaguhin yan kasi binalance mo na nga yung carbon pati hydrogen based on this. So, wag mo ito babaguhin. Baka kasi mamaya lagi mo ito 3 na lang yan. No? Wag ganun. Magagalit ako. Okay. So, yan. Wag mo na baguhin siya. Ito na lang. Okay. Ito na lang kasi siya pa yung walang coefficient eh. So, 24 na oxygen ang kailangan natin makuha dito. Kaso 2 lang yung nandun. So, kailangan times 12. Yan. Balance na siya. Okay. So, ganun lang yung combustion reaction. And most of the reactions most of the reactions dito sa ating subject ay combustion naman. Okay. So, yan. Hopefully, na-review kayo sa balancing ng combustion. Okay. So, again, sabi ko nga, puro combustion yung reactions natin dito. Okay. What else? No? Other than knowing how to balance the combustion reaction, kailangan marunong kayo mag-stoic. No? When you say stoic, stoichiometry, that is the relationship of the moles of the species in a chemical reaction. Okay? So, suppose you have this reaction, yung capital letters, yun yung chemical species mo. Yan yung species mo. And yung small letters, yun yung yun yung moles, no? Okay? So we treat the coefficients of the balance equation as the moles of the substance necessary, no, to carry out the reaction. Okay? So moles yung small letters, no. Moles yung numbers na nilalagay natin sa gilid ng ating chemical species. Okay? Kunwari, from this reaction, if I have 1 mole of sucrose, kunwari, if I have 1 mole of sucrose, how many moles of oxygen ang kailangan ko? How many moles of oxygen? Gagawin mo, tingin ka lang, ano yung coefficient niya? Ito 1, ito 12, edi 12. Okay? Yung ginawa natin na yon is stoichiometry. Yun na yung stoic, no? Inaalam mo gaano karami yung proportion ng compound na to sa compound na to. Okay? So you are determining the proper ratio nila so that the reaction is complete. Okay? So kung may isang mole ka nito, dapat 12 moles nun meron ka. Okay? What if I have 10 moles of this? If I have 10 moles of sucrose, ilang moles ng oxygen kailangan ko? Kailangan ko ng 120. Okay? So as you can see, 1 to 12 talaga yung factor nila. No? So if I have 5 moles of this, kailangan ko ng 60 moles nito. Okay? 10 moles of this, 120 moles. No? Ibig sabihin, kailangan nakatamang proportion. And that proportion can be obtained from the coefficients, no? Which we treat as the mole of the substance. Okay? So, yun. So, yun yung stoic, no? Also, you should know how to convert mass to moles, no? Kasi sabi nga natin, yung moles, ito yung interrelation ng chemical species, no? And what if, let's say, I have 5 grams of this? Ilang grams nun yung mapoproduce ko? Pag ganun, kailangan mo na mag-convert. No? You convert the mass into moles and vice versa. Okay? So when converting mass and moles, we use this triangle. This is very, this is very important. No? So this triangle allows us to convert the mass moles. No? Paano yung ginagamit? Kunwari, hinahanap mass. You are solving for the mass. Anong gagawin mo? Ito yung natira. I-multiply mo sila. Pag magkatabi, multiply. Kapag magkapatong, divide. Okay? So, yun yung purpose ng triangle na to. Naalala niyo to sa high school physics niyo. Yung V equals IR. Diba? Ganun yun eh. Ayun. Pwede mo rin yung gamitin dito sa moles. No? Kunwari, hinahanap mo yung mass ng substance mo, gagawin mo, you multiply the mole by the molar mass kasi magkatabi sila. Okay? Kunwari, hinahanap mo yung mole ng substance mo, gagawin mo, you divide the mass over the molar mass. You will get the mole. Okay? Hopefully, naalala yan. The unit of mass is usually grams. Okay? The unit of the molar mass is usually grams per mole. And the unit of mole is obviously just the mole. Okay? So, yan. So, this is also another, parang ganito lang din yun, pero ayan. Mass to moles, divide by molar mass. Moles to mass, multiply by molar mass. Hopefully, naaalala pa yan. Ayan. Review lang naman kasi tayo. No? Ito, isang example. One example, what is the mass of carbon dioxide produced when 105 grams of methane burns completely in the air, no? Paano yan? Wala tayong equation. Kailangan may chemical equation. Pag nakita mo na yung mass, completely produced, no? Pag nakita mo mga keywords na yan, magpanic ka na slightly. Okay? Pag nakita mo yung mass, yung produce, no? Tapos yung complete reactions, ayan. Okay, kasi kailangan niya ng chemical equations. Kung walang binigay, ikaw gagawa. Okay? So, marunong ba kayo gumawa ng chemical equation? Dapat marunong kasi mataas kayo sa Gen Chem, di ba? So, gagawin natin yan. So, turuan ko kayo ulit kung paano kung nakalimutan na. Okay? So, this is combustion reaction. Obvious naman eh. Sinabi yung word na burn, di ba? Di ba pag sinabi nating burn, that is, synonymous to combust, no? Pag may nasusunog ka, malamang may nagko-combust dyan. Okay? So, ganun. So, synonymous yung dalawang yan. Okay, this is combustion reaction and what's the formula? Fuel plus oxygen forming CO2 plus H2O. Now, what is the fuel? E di yung yon, hydrocarbons mo. Okay? Yung nilista ko kanina, hydrocarbon. Ito yon, methane. So, that serves as your fuel. Then, from that, you can now balance them. Balance na lang. Isang carbon, isa, okay na. 4 na hydrogen, 2. So, times 2. Bilangin oxygen, 2, 4. Okay, so times 2 to. So, yan, balance na yung ating equation. Kailangan mabilis na kayo, ha? Kasi tapos na tayo sa Gen Chem, no? Pero kung hindi pa mabilis, okay lang din. No? Hindi ko naman kayo i-judge, no? Mahalaga, bibilis din tayo over time, ha? Okay. So, we are now able to balance the equation. Again, review class lang tayo ngayon, kaya mabilisan tayo. Ayan. So, since we now have a balanced equation, we can now do stoichiometry, no? Kung alam ko yung moles nito, alam ko yung moles ng carbon dioxide. Kasi, using stoic, isang mole nito, katumbas nun, isang mole din. Okay? Ang tanong, isang mole nga ba ng methane meron ako? Hindi ko alam. Kasi grams binigay sa akin eh. Kung mole sana, di tapos na problema ko. Times ko na lang siya sa coefficient na. Kaso gram binigay sa akin. So, I need to convert the grams to mole. Okay? So, doon na papasok yung ating mole relationship. No? O, using the triangle. Yung Illuminati triangle. No? Ang Gen Chem ay gawa-gawa lamang. Okay. So, kunwari, you are solving for the mole, you divide the mass by the molar mass. No? Divide mo yung dalawa. So, mass methane divided by the molar mass of methane. Ano yung mass ng methane? Given naman eh, given. No? So, that's 105 grams. Divided by the molar mass of methane. Paano kinukuha molar mass? Titingin sa periodic table. Okay? So, carbon is 12.011 grams per mole. Hydrogen is 1.008 grams per mole. Kaso, 4 yung hydrogen mo according to the formula, no? May subscription 4 eh. So, times 4 mo yan. Okay? So, ilan yan? Pipindutin ko na lang calci ko para malaman ko kung ilan yan. Okay, so the molar mass of methane is 16,043 Gmol. Gmol or grams per mole. Okay, so yan. Divide nyo na lang. Divide. Divide natin yan. 105 divided by 16,043. That's 6.54. Nag-round off na ako ha. Ayan. Ang daming numbers eh. Sabi ko nga sa inyo, yung quiz naman ay multiple choice. Ayan, nag-round off na ako. So we have 6.54 moles ng methane. Balik tayo sa stoic. Diba sabi natin, if I have 1 mole of this, I have 1 mole of that. Diba? Paano ko nalaman na 1 mole, 1 mole? Kasi yung coefficient nila ay 1. Isang mole neto, 2 moles neto. Isang mole neto, 2 moles nun. Isang moles nun. Isang mole neto, 2 moles nun. Okay? So yung coefficient magsasabi kung ilang moles ng kabilang molecule yung magagawa mo out of this. Okay? What if I have 5 moles of this? I will have 10 moles of oxygen, 5 moles of CO2 and 10 moles of water. Okay? Ano lang, tamang ratio and proportion lang. Ito yung question. If I have 6.54 moles of this, ilang mole na ito yung magagawa ko? 6.54 din. Bakit? Kasi nga, 1 to 1 yung ratio nila. Okay? So, 1 to 1. Okay? So, we can say that 6.54 moles of this is equal to 6.54 moles of that. Okay? So, we can also say that, to get the mole of carbon dioxide, that's equal to the mole of CH4 times the conversion factor, which is yung nasa equation. 1 mole CH4, 1 mole CO2. Okay? So, ito na yung kanilang relationship. 1 to 1. Okay? So, basically, 6.54 lang din yan. Hopefully, naalala pa tong process na to, ha? Since we now have the moles, we get the mass. No? Paano yan? Balik ulit tayo sa Illuminati triangle. Okay? Ang gawa-gawa lang. Okay? Ayan. Ayan. So, ito. Hinahanap mass. So, we need to multiply moles and the molar mass. No? So, mass ng CO2 is equal to mole CO2 times the molar mass CO2. Mole CO2, 6.54 moles. So, ano yung molar mass ng CO2? 44.0. Ano yun? Dati kabisado ko yun eh. 44.009 yan. Sir, saan galing yan? Ano yung atomic mass ng carbon? 12,001. Oxygen, 15.999 times 2. Pag-add mo yon, you will get this, 44.009. Okay? Kailangan marunong pa rin yan, ha? Hindi pwedeng hindi marunong. Okay? So now, we can get the mass of CO2. Just multiply the mole by the molar mass. So we have 287.82 grams. Okay? So yan. So if you have 105 grams of this, you will get 287 grams of that. Okay? So yan. So important to sa sa subject natin na to kasi again, engineering, tayo, chemistry for engineers, no? So we are focused on energies, no? So energy tayo, and one way to get energy is to burn materials, no? Yun yung ginagamit natin, no? To get electricity. Okay? So I will leave this to you as your assignment na lang din. Okay? Para medyo mabilis tayo. Ayan, naka-grams lang din naman. Okay? Ito din. By the way, dito sa previous problem, okay. So this previous problem involves the knowledge of limiting and excess reagent. Naaalala? Hindi. Kailangan maalala to, no? Okay? Kasi mataas tayo sa Gen Chem. So, kailangan maalala nyo yan. So, anong ganap ng limiting and excess reagent, no? Kasi, in a chemical reaction, hindi, wag na lang chemical reaction, pagluluto. Kunwari, magluluto ka ng ng adobo. Okay. May 1 galon ka ng toyo, 1 kilong baboy, 1 galon ng mantika, tapos 1 sakong laurel. Ang dami, no? Lahat ba yung gagamitin mo? Hindi, di ba? Okay. So, hindi lahat ng yon gagamitin mo sa chemical reaction. Okay. So, ibig sabihin nun, dito din, if you have 10 grams of butane and 10 grams of oxygen, hindi lahat yan magagamit. Okay? So, ganun din sa ganun din sa adobo recipe ko, no? Yung 1 galon ng toyo, di mo ilalagay yan. Magkasakit ka pa sa pantog, di ba? Sira pa kidney mo, no? Instead na mabuhay ka pa, delikado pa buhay mo dahil sa toyo, no? O yung 1 sakong laurel, malamang hindi mo uubusin yung lahat, ano? ano yun, laurel na may konting adobo. Walang ganun, no? So, ibig sabihin, yung chemical reaction, if you're given certain amounts of chemical species, no, hindi lahat yun magagamit, no? Okay? So, that means you have to determine which one is the limiting and which one is the excess reagent. Paano ginagawa yan? Magi-stoic ka. Okay? Stoic lang yan. So, ganito gagawin nyo. So, the reaction is ganito, butane plus oxygen. Kayo na magbabalance niyan. Bibigay ko yung answer, don't worry, no. Sa deadline ng ating prob set, after nun, i-upload ko yung answers, okay? Ganong ginagawa ko. Yan. Kahit face to face, nagsasagot kami. Okay? Para may reviewer. Okay, so gagawin nyo dito is, kunwari, you have 10 grams of butane. Alamin mo kung gaano karaming CO2 magagawa mo. And then if you have 10 grams of this, alamin mo kung gaano karaming CO2 ang mapoproduce mo. Okay? Kung sino yung may pinakaunting CO2 na na-produce, least CO2 ang mapoproduce, siya yung limiting reagent. Naalala yung ganitong process? Sana naaalala, no? Kung hindi, okay lang naman, pero kailangan alalahanin yan. Kung sino yung nagbigay ng pinakaunting products, siya yung limiting reagent. And the limiting reagent, sabi nga natin, limiting. So, siya yung nagdidikta kung gaano talaga karami yung products na magagawa mo. Okay? Siya yung magdidikta kung gaano karaming CO2 yung kaya mo ma-produce sa reaction. Okay? Ibig sabihin, yung excess reagent, ay excess nga eh. Ibig sabihin, sobra-sobra yon. Hindi mo yun magagawa talaga. Ang magagawa mo in a chemical reaction is the limiting, no? O kunwari, balik tayo sa usapang adobo ulit, no? You have 1 kilo ng baboy, 1 galon na toyo, 1 galon na mantika, 1 galon na suka, 1 sakong paminta, 1 sakong laurel. Sa tingin nyo, sino yung magpe-predict ng reaction doon? Sino yung magpe-predict kung gaano karami yung magagawa mong adobo? Yung baboy. Kasi siya yung 1 kilo eh. Siya yung limiting reagent eh. Kasi siya yung may pinaka-onting product na mapoproduce. Okay? So, ibig sabihin, kapag naluto mo na 1 kilong adobo, yung 1 kilong baboy, wala na. Tapos na yung reaction. Hindi ka na pwede makagawa ng excess, no? Kasi nga, limited na lang yung resources mo. So, ganun lang din gagawin nyo dito. Alamin nyo sino pinaka-onti yung product na mapoproduce, no? And kung sino yung onti yung product mapoproduce, siya yung limiting reagent. And the limiting reagent will tell you kung gaano karami yung product talaga na mabubuo, no? Okay? So, yun lang yung review natin dyan. Okay, so I will leave that to you as assignment, no? And i-upload ko yung answer after the deadline of the assignment, which is May 8 pa naman. Matagal-tagal pa. Kunwari, ito naman. You have a gas, no? Pag gas naman, i-apply mo sa stoichiometry, then you need to use the PV equals nRT, the ideal gas equation. This will help you to find for the moles of a gas, no? So the moles, the N, no? Okay? So yan, so makakatulong yan to find the moles of the gas, no? Pag nakuha mo na yung moles of the gas, edi do the usual Stoic process, no? Okay? So the pressure is in the atmosphere units, volume is in liter units. R is the gas constant, which is 0.08206 liter ATM per mole Kelvin. Then you have the temperature, it should be in Kelvin, okay? Okay, so depending on the temperature, the behavior of gas will be different, no? Okay, so pwedeng mas lumaki yung volume niya kapag mas malaki temperature. Charles law yon. Okay, so ganun lang. Okay, so yan. Kailangan alam niyo pa yan. Okay, so may additional 2 problems kayo dito. Okay, so yan, additional 2 problems. Okay, so punta na tayo sa mismong Chem 4Eng part, no? So intro pa lang yun eh. Review pa lang yung ginawa natin. Ngayon, introduction na tayo. Okay, So sabi natin, this subject is focused on harnessing energy from materials, no? And the energy source here is what's called the fuel, no? When you say fuel, ito yung definition niya. Fuel are dense repositories of energy. Ibig sabihin, ito yung mga substances na may taglay na enerhiya sa loob niya. All we have to do is to react it, no? Para yung energy na yon lumabas. Okay? Now, for example, yung papel na to, may energy ba dito? Yes, may energy dito. Kasi pag sinunog ko to, it will release heat, no? Ibig sabihin, may energy dito. May nirelease siyang energy pag sinunog ko to Iinit Okay? Ibig sabihin, this is a fuel. Tayo, fuel ba tayo? Yes, no? Okay? So, kasi may mga molecules tayo na pwede sunugin sa katawan, no? For example, yung fats natin, fuel yan. Okay? So, kunwari, medyo malaki na yung beer belly mo. Sabihin mo, ay, hindi yan beer belly. I call it, repository of energy. Okay, ganon. Kasi, may energy, ka doon, storage, no, in the form of glycogen. Pwede mo sunugin yon, no, para maging energetic ka, no. Okay, so ganon. Sa Chem 4Eng, we are focused on the fuels. No? And again, fuels are dense repositories of energy. Ibig sabihin sila yung mga maliliit na material pero pag sinunog mo, maraming energy kang makukuha. For example, papel. No? Kaya kahoy. No? Imagine mo kahoy, pwede kang makaluto ng pagkain. Di ba? Ayun. So, yan, ng fuel natin. And there are many classification of fuel. It could be solid, liquid, and gaseous. No? So here are some common example. The solid fuel, alam natin yan. Especially, alam natin yung uling, no? Sangyup. O kaya, pag sa bahay, naubusan ng LPG. Minsan, uuling. Kaya, pag barbecue, uling, di ba? So, kapag itong uling na to, sinunog mo, may energy ka pang makukuha dyan. Umiinit yan, di ba? Nagliliyab yan, no? So, ibig sabihin, charcoal is a source of energy. So, ibig sabihin nito ay fuel. Ang kahoy, ganun din naman, di ba? So, kunwari, wala kang uling, edi maghanap ka ng puno, sunugin mo yun, no? Okay. So, yun, you will get energy from that, no? And ito yung iba't iba pang forms, no? A coal is a carbon compound, no? Mga hydrocarbon compound yan, no? Na ito yung ginagamit ng ating energy supplier, Meralco, no? Sa pag-produce ng kuryente. The majority of the kuryente is from the coal energy. So, sinusunog nila yan and the heat produced in that reaction is converted to kuryente. Okay, so yan. Liquid fuel, familiar tayo dito. We have the LPG. Meron kayo niyan sa bahay, no? So, LPG, liquid yun nasa loob talaga nun, no? Kaso, very volatile gas yun. Ibig sabihin, mag-evaporate din yun, no? Kaya, mapapansin nyo, pag binuksan nyo yung tangke nyo, hindi bumubulwak yung tubig doon, no? Naging gas na lang siya. Kasi yung liquid dito, under high pressure yun. Pero kapag binuksan mo yung takip, gas na siya uli, no? Magko-convert siya into gas, no? Oil shale, ito yung mga crudo, no? Mga crudo na kinukuha sa Philippine rice, no, na inagaw na sa atin ng ibang bansa, no. Yan. Gaseous fuel, pag gaseous fuel naman, edi mga gas form na. For example, yung acetylene torch, no. Pag nag-welding, may tangke ka ng acetylene, no. So pag sinunog mo yung acetylene, it will produce heat, no. And as a result, matutunaw yung bakal. Kaya siya ginagamit sa welding. Hydrogen gas. So ito, ano tong picture na to? Ito yung nasa Apollo spacecraft, no? Ayun, the one that went to the moon, okay? And back, no? So in Apollo spacecraft, kung tataka kayo, no? Tataka siguro kayo, no? Paano kaya sila umiinom doon? Nagdala ba sila ng sobrang daming tubig? No? Wilkins ba dinala nila? Hindi. Ang dala nila ay hydrogen gas, pati oxygen gas. Okay? So, ayan. So, when hydrogen gas and oxygen gas are combusted, ano yung napoproduce? Water. Ayun. Dun, yung, napoproduce ng combustion ng engine nila sa likod, napoproduce ng tubig, yun yung iniinom din nila. Okay? Talk about being so, resourceful, no? Okay. Yung papel na to, pag sinunog ko to, may water na lalabas dito. Ibig sabihin, pwede ko inumin yung water na yon, no? Ganun ginagawa sa sa spacecraft, no? Yung mga pumupunta ng Mars, Mars wala pa pala. Pumupunta ng outer space, no? Ganun ginagawa nila. So kung wala silang tubig, edi yung fuel nila iinumin nila, no? They will just combust it, it will produce water, then they will collect it. Pwede mo na inumin. Okay? Other fuel, I have here the uranium-235, which is the fuel for nuclear power plants, no? Ayan, so ginagamit yan. Madidiscuss natin ito pag nag-nuclear chem na tayo. Okay? So, yan. Pwedeng atoms din yung fuel natin, no? Basta mga chemicals, no, na nagre-release ng energy, fuel tawag doon. You may ask yourself, no, bakit may energy na napoproduce doon? Okay? Bakit kaya kapag sinunog ko papel, may energy na lumalabas doon, no? Kasi ganito nangyayari. Sa chemical compounds daw kasi, remember may chemical bonds doon, di ba? Nag-Lewis structure kayo dapat nung Gen Chem, di ba? So naalala nyo, the atoms are connected, no? So suppose we have CH4 plus oxygen producing CO2 plus H2O. Balance natin. Remember that itong mga formula na sinulat ko, molecules yan, di ba? Ibig sabihin, connected yung mga atoms na yan. CH4, ganito itsura niyan. Okay? So, during the chemical reaction, what happened? Yung CH4, naputol yung bonds na yan. Okay? So, naputol yung bonds na yan. Ano naging product niya? Naging CO2 na lang, no? Okay? So, when these bonds break, no? Pag itong mga bonds na to nasira at napalitan, may energy involved doon. Pinutol mo yan, may energy na lalabas doon. Pag dinugtong mo yan, may energy din na lalabas doon. Okay? So that means, in a chemical reaction, yung breaking and formation of chemical bonds, that is the reason why we have energy sa ating compounds. No? Pag pinutol ko yung hydrogens dito, nilagay ko yung kay oxygen, may energy na lalabas doon. Okay? The formula we use to determine how much energy can be obtained in this chemical reaction is this. No? The sum of the energy of the bonds broken minus the sum of the energy of the bonds formed. Okay? So these are the chemical bonds. So kapag pinutol mo yung mga yan, there are corresponding energies involved in the process. Okay? So siguro ito na-discuss yung Lewis structure sa Gen Chem nyo, pero ito hindi na-discuss to, no? Okay. So we will discuss this, no? Okay. And suppose we have this reaction, we have methane burning an oxygen to produce carbon dioxide and water. Ang tanong, gaano karaming energy mapoproduce mo dyan? Okay? So, paano mo gagawin yan? Paano mo sasagutan to? Gaano karaming energy mapoproduce dito? So, you should know first the correct structure of the molecules. No? Kailangan alam mo yung correct Lewis structure niya. So, ang methane, ito yung itsura niya. Kailangan marunong na kayo mag-Lewis structure, ha? Ayan. Ang oxygen, ganito itsura niyan. O, since dalawa yan, edi dalawahin natin. O, CO2, ano itsura niyan? Ayan. H2O, o, dalawa. So, ganito itsura niyan. Okay. So, to get the amount of energy produced in a chemical reaction, we use the formula delta E equals energy of the bonds broken minus energy of the bonds formed. No? Itatrack mo ano yung mga naputol, tapos ano yung mga nabuo. Okay? So, tingin tayo sa left side. Ano yung mga naputol sa left side? Left side, tapos right side. Compare natin. O, yung carbon, puro hydrogens. Yan ngayon, oxygens na. Ibig sabihin, naputol yung mga CH bonds. Itong C pati H na to, naputol yan. O, gano'ng karaming energy involved doon? So, according to this table, yung CH bond, pag pinutol mo yan, 410 kilojoules per mole yung energy niyan. Okay? So breaking this is equivalent to 410 kilojoules per mole. Ito pa lang yun. Apat yan. Okay? Ibig sabihin nun, times 4 yan. Okay? So breaking the CH bond, no, is 410 kilojoules per mole ang energy. Kaso times 4 kasi apat yung pinutol mo eh. Okay? Pinutol mo yon. Okay? Kasi pagdating sa product side, yung carbon hindi na nakakonect sa hydrogen. So basically, pinutol mo talaga sila. How about the oxygens? No? How about the oxygens? O yung oxygens, naputol din sila, no? Kasi originally, silang dalawang katabi. Ngayon, sino na yung katabi nila? Si carbon, pati yung hydrogen. Ibig sabihin, pinutol mo yung double bonds na yan, no? Pinutol mo rin yan. Tanong, ano yung energy involved dyan? No? Balik ulit tayo sa table. When breaking oxygen double bonds, no? Ito yung energy involved. 498 kilojoule per mole. So, ibig sabihin, pag pinutol ko to, 498 kilojoule per mole yan. Ito rin, 498 kilojoule per mole. Okay? So, pag brinake ko yung oxygen double bond, 498 kilojoule per mole. Times 2 kasi dalawa yung oxygen molecules ko eh. Okay? Kasi may stoic factor ako na 2 doon. So, times 2 yan. Okay, so kunin natin yung energy of the bond broken. Ipag-add lang natin yan. So, 410 times 4. 498 times 2. Okay. So, ilan yun? 16, 1640. How about this one? No. That's 16, carry 1, 9, 19, carry 1, 8. No. 896 now. Okay, total natin yan. You have 6, 3, 5, 2. Okay. So the energy of the bonds broken is 2,536 kilojoules per mole. Okay. Bond broken pa lang yan. So ganun karami energy yung kinailangan mo to cut all those bonds. No? Pag naputol na yan, mga floating atoms na lang yan. Floating atoms sila. Okay. Then yung mga floating atoms na yon magko-combine to form the products. Okay? Ngayon, alamin naman natin sino-sino yung mga magsasama-sama at ano yung energy involved there. No? Okay, so EBB natin, energy of the bond broken is 2536. Okay? Sulat natin dito, 2536. O ngayon, EBF, no? Bonds form, no? Sabi ko nga, pag pinutol mo yung mga bonds, lulutang na yung mga atoms. Pero magsasama-sama uli yan to form the products, no? Ngayon, ano yung mga bonds na nabuo na? Okay, ano na yung mga na-form? Okay. Tignan mo. Yung carbon, oxygen. Carbon-oxygen bond, meron na tayo. C double bond O, meron na. Ilan yon? Dalawa. Meron sa left, meron din sa right. C double bond O, C double bond O. Ibig sabihin, dalawang ganun. Ano energy involved doon? Sabi dito, 732 kilojoule per mole times 2. Okay, so tignan mo lang, ito, C double bond O, nabuo yan. Ilan? Dalawa. Meron sa left, meron sa right. Anong energy yon? 732. Times 2 mo yan. 732 to, 732 yan. Ano pa yung mga nabuong bonds? OH bonds, no? Okay. So ito, OH bonds. Napagdugtong mo na sila eh. Ilang OH bond meron ka? 1, 2, 3, 4. 4. So anong energy kapag OH bond daw? Sabi, 460. Ayun, OH, no? 460 yung energy involved doon. Times kung ilan yung bonds na nabuo, 4. Okay? Ipag-add natin lahat yan. 732 times 2, 4, 6, 14. Okay? 460 times 4, 0, 24, 2, 16, 18. Okay. Add them na lang, ipag-add na lang natin yan, equal yan sa 40133. Okay? 3304. Ang energy for the bonds formed. Okay? 3304. Okay? So ngayon, alam ko na yung energy of the bonds broken. Alam ko na yung energy of the bonds formed. Pag-subtractin ko na lang sila to get the overall energy of the reaction. Okay? So, subtract ko na lang sila. Ayan, hindi ko na i-mental yan. Weakness ko yung subtraction kapag mental. Ayan. So, the delta E is negative 768 kilojoule per mole. Okay? So, that is the energy involved in the combustion of methane. Okay? So, pwede mo malaman gano'ng karaming energy makukuha mo by using this table. Okay? Alamin mo lang, ano yung energy ng bonds broken. Tingin ka dito sa table. Hanapin mo yung CH bond. Ayun. Times 4 mo yan kasi 4 yung puputulin mo. O yung O double bond O. Hanapin mo sa table. Ito yon. Times 2 kasi dalawa yon. O bonds form naman. O. Dalawang C double bond O. Ito yon. Times 2 mo yan. 4 na OH bond. Okay. So ano yon? Times 4. Ayun. Okay. So by just subtracting them, you will get the energy of the reaction. Negative 768 kilojoules per mole. Pag negative sign yan, ibig sabihin, ano yan, magre-release yan ng heat. No? Mainit yan. Okay? Exothermic yan. Pag negative. Although, di-discuss pa natin to sa next chapters. No? Di-discuss pa naman natin yan, kaya skip na lang muna natin. Okay? So this is how we get the energy we can get from our fuels. Now, you can do this, no? Kunwari, may gasolina ka. Alamin mo yung chemical formulas nila and then the correct structure. Okay? Important na alam niyo yung mga yon. Yung how to draw the Lewis structure. No? Kasi kapag hindi mo kaya mag-draw ng Lewis structure, di mo malalaman kung ano yung bonds na ng mga naputol at mga nabuo. No? So, kailangan alam niyo yung chemical structures nila. Okay? So, yun. Kung gusto niyo manood kung paano uli yun, no, ginawa, meron naman ako sa YouTube, no, na video about that, no, Lewis structures, no. Okay? So, siguro bigyan ko na lang kayo ng link after the class. Okay? Kunwari, ito naman, glucose. Siguro ito, bigay ko na lang sa inyo as assignment na lang. Group assignment uli yan. Okay, so glucose, oxygen, CO2, H2O. O yung O2, alam nyo na, ganito lang yan. Times 6 lang yan. CO2, ganito yan. Times 6 uli yan. Water, ganito lang yan. Times 6. How about the glucose? The glucose is, ganito yung itsura niyan. C6, H12, O6 na. C double bond O H. Pwede nyo naman i-google pero ipapakita ko na lang din. Ay, masyadong maliit yung space ko. Teka lang. Pwede nyo to i-google na. Pero bibigay ko na lang din yung structure niya para alam nyo. 3, 4, 5, 6. Lagay ko na lang lahat sa right. Actually, merong left, right pa yan eh. Okay. Ayan. I think ito yung ito yung structure ng glucose. C6, H12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, O6, 1, 2, 3, 4, 5, 6. Okay, so that is the structure for glucose. Pakita ko yung individual bonds, no? So, alamin nyo na lang ano yung mga naputol. Okay? Ayan. Okay, so bakit siya group activity? Para magtulong-tulungan kayo kung ano yung mga mapuputol. Ayan. Okay, so yan. So ito yung mga bonds, no? Ayan. Kunwari, ayan, bilangin mo, ano yung mga naputol dito? Ito. Lahat yan, putulin mo yan. Putulin nyo yan lahat. Okay? Tapos, pagdugtong-dugtongin nyo uli yung mga atoms, no? Ano yung mga na-form? Alamin nyo, gano'ng karaming energy dito? Gano'ng karaming energy dyan? Ito yun. Ito yun. Ayan yung energy dyan. Gano'ng karaming energy na putol dyan? Ito. Gano'ng karaming energy to? Ito. Okay? So, ganun gagawin nyo. Ito, gano'ng karaming energy dyan pag naputol yan. Ayun. Okay? So, basically, lahat putulin mo. Then, identify gano'ng karaming energy involved doon. Okay? So, yan. Yun na yung bonds broken. And also, don't forget this one. Puputulin mo rin yan. Okay? So, ito yung energy involved yan. So, yun yung bonds broken pag pinag-add nyo yun. Bonds formed naman. Parang yung kanina lang din. CO yun na buo. So, ito yun. And then, OH bonds yun na buo. Ito yun. Okay. Times 6. Okay. Then, ipag-subtract mo sila, you will get the energy change, no, for the reaction. Okay. Pag negative yan, ibig sabihin, mainit yan, no. Magre-release yan ng heat, no. Katulad ng sa uling natin, sa papel, pag ininit mo yun, mainit, di ba? Pag sinunog mo yun, mainit. Kasi negative yung energy, no. Okay. Ibig sabihin, naglalabas siya ng energy. Okay. So, yun. It is also, ayan group assignment na lang yan. Binigay ko na sa inyo yung idea. Up for you to solve na lang. Okay? Just follow the steps I gave you dito. So, alamin mo lang yung mga naputol. Ito yung energies nila. Ipag-add mo yun. Alamin mo yung mga nabuo. Dito yung energies nila. Ipag-add mo yun. Then, pag-subtract nyo lang sila. Okay? Bonds broken minus bonds formed. You will get this. No? Pag negative yun, ibig sabihin, mainit yan. Pag sinunog. Okay? Ngayon naman, let's talk about calorific value. When we say calorific value, it refers to the energy released per gram or per kilogram of your material. No? So, kunwari, if you have hydrogen, ito yung kanyang calorific value. 120 megajoules per kilogram. No? So, that's 120 million joules per kilogram. Sobrang init niyan. Kunwari, LPG. When you burn 1 kilo of LPG, that produces 46 million joules of energy. Okay, so basically, 4 times na mas malakas ang energy ng LPG kaysa sa hydrogen gas. No? Pero kung titignan nyo, yung nuclear, uranium, nuclear power plant, look at the energy density, the calorific value niya. Gigajoules, no? 3,900 gigajoules, no? So, kapag sinabing giga, ano ba yan? Ang mega is 1 million. Giga is billion. So, basically, this is 3.9 trillion ang energy na makukuha mo sa uranium compared to other materials, no? So, that's why sinasabi sa inyo parate that nuclear energy is a very high density material, no? So look at the calorific value. Sobrang dami niyang energy per kilogram compared to other materials. No? Kaya it is true that nuclear energy is a very efficient way to produce energy. Just so happened na hindi lang siya gusto ng mga tao. But as scientists, no, as engineers, dapat ma-appreciate natin siya. Okay. Hindi porket may nuclear energy, ibig sabihin nun may mga zombie na. No. Okay. So, yan. So, ito yung mga ayan. So, ito yung mga energy ng ating mga materials. No? Kapag pagkain naman, depending on the components of your food, there is associated energy dyan. No? So, ayan. Kunwari, kumain ka ng carbohydrates. So, alamin mo kung ilang grams yung carbohydrates na kanain mo. Kunwari, 500 grams na kanin. Grabe gutom natin nun, no? Gano'n karaming energy makukuha mo doon sa 500 grams ng kanin. Multiply mo yan dito. Kilojoule per gram. So, 17 times 5. Ano yan? 8,500 kilojoules ang makukuha mo. Okay? So, ibig sabihin, pag kumain ka ng kalahating kilong pagkain, ganito karaming energy makukuha mo. Okay? Ang dami na yan. Enough na yan halos for one day. No? So, ganun. O kunwari, uminom ka ng alak, may energy mo makukuha doon, no? Ang problema, lasing ka nga lang. Okay. So, yan. Pag uminom ka alak, may energy pa rin doon kasi alcohol yan, fuel yun eh. Di ba, nagliliyab yung alcohol, di ba? Ayun. Sabihin, may energy ka makukuha doon. Mga proteins and fats, no? Mapansin nyo, sa pagkain natin, sasabihin nyo siguro, uy, yan, taas ng energy, oh. Taas ng energy ng alcohol, mag-inom kaya ako. Okay lang. Kaya nga sa ibang bansa, no, Russia for example, umiinom sila ng alak. Bakit? Kasi yung alak, malakas yung energy nun, no? So as a result, iinit katawan nila. Okay? Kasi kapag nasa cold climate ka, necessary talaga uminom ng alak para mabuhay ka. Okay? Hindi yun bisyo. Sa Pilipinas, bisyo yun siguro. Pero sa ibang bansa, hindi yun bisyo. Ano yun? Kailangan yun para mabuhay. No? Wala mo talaga uminom ng alak doon para mabuhay. Kasi kung hindi, lalamigin ka, hypothermia. Okay? So, yan, alcohol. Yun yung reason ba't yung mga nasa Russia, umiinom ng vodka parate. O, fats. Fats naman, mataas yung energy niyan. Okay? So, ibig sabihin, pag kumain ka ng sisig, sarap, no? Lakas ng energy mo doon. The problem nga lang is that yung mga fats, pwedeng maging bad cholesterol yan eh. So, pwede ka mamatay naman din. So, kailangan nasa proper, proper amounts of energy, no? Okay, so ito, I will give this as group assignment lang din. So basically, nabigay ko naman kung paano mag-compute ng energy from the food material. Bibigay ko yung idea dito. Kunwari, ang chocolate daw may 10 grams ng fat, 24 grams ng carbs, at 4 grams ng protein. Gano'ng karaming energy makukuha mo? Okay? So sabi dyan, 10 grams ng fats. So times 10 mo yan. 24 grams ng carbs times 24 yan. And then 4 grams ng proteins. Ipag-add mo lahat yan. Ganun karaming energy makukuha mo. You can apply that sa ating pagkain. Kunwari, ito yung pagkain ko, rebis ko. Sa likod nun, may makikita kayong info. Ayan. Nakalagay dyan, total fat, total calories, total carbohydrates. Gano'ng karaming energy makukuha ko dito? Kunwari, sabi sa rebis ko, 160 ang calories total. Ayun na pala yung total energy, 160 calories. No? Pwede mo yung ma-derive, no? So sabi dito, this is composed of 7 grams fat. Times mo yun sa 37. And then 21 grams carbohydrates. Ayun, no? So ganun lang. So, multiply mo lang sila dyan. And you will get the calories in the food. Okay? So, yun yung ginagamit ng nutritionist pag magre-recommend sila ng food. No? Okay? So, yan. Okay na bahala maganda. I-add nyo na lang yan. Ganun lang. No? So, kunwari, sa quiz, may nakita kayo. Yung kinain ko kanina is 5 grams carbohydrates, 10 grams na fat, and 20 grams na alcohol. So, minom pa ako ng alak. Ang ganuhan namin na yung energy ko. Ayan. Pwede ko pa-solve yun sa inyo. Okay? Okay. So, we are now on the last part na. No? Review lang naman to kaya mabilis-bilisan lang yung ginagawa natin. Itong thermodynamics, didiscuss ko pa ulit sa Wednesday. No? Pero daanan na natin ngayon. So when you say thermodynamics, thermo, ibig sabihin energy, dynamics, changes, okay? So when you say thermodynamics, it is just about the changes in the energy, okay? So the definition is this, now very straightforward. Thermodynamics is a study of energy conversion from one form to another, no? So this is a study wherein malalaman natin, no, ano nangyari sa energy? Was it converted to one form or the other? Okay, so thermodynamics ang sasagot doon. Okay? So, for example, solar panel, may thermodynamics doon? Yes, no? Yung solar energy from the sun, no, convert into kuryente. That process of converting energies, ang sasagot doon ay thermodynamics, no? O, nari sa sasakyan, o yung, fuel mo, naging motion ng car. Okay, so from chemical energy, naging siya, kinetic energy. O, thermodynamics sasagot doon. Okay? Actually, pwede mo computein, no? Gaano karaming energy yung kailangan para gaano karaming fuel kailangan para umandar yung sasakyan, no? So, yan. Thermodynamics ang sasagot doon. Okay? So, pero since we are talking about energy, let us define it. No? So when you say energy, it is the capacity to do work. And when you say work, that is the changes resulting from a process. Ibig sabihin nun, when we say energy, this is dito natin malalaman if a motion can be done, no? Kung pwede ba gumalaw yung object, no? For example, itong cursor ko, pag ginalaw ko yan, may energy doon. Ayan, ginalaw ko siya, may energy doon. Ayan, ginalaw ko, may energy doon. Okay? Ibig sabihin, every time there is a possible chance for change, no? Kung pwede gumalaw yung object, ibig sabihin may energy doon. So basically, lahat ng bagay may energy kasi lahat sila may potential to move. Okay? And ito yung mga uri ng energy natin. Alam natin to sa physics dati, nung tayo, elementary, nung high school tayo. We have the potential energy, that is the energy in at rest. Okay? So ibig sabihin, hindi yang gumagalaw, yes, pero may energy yan. Bakit? Kasi sabi ko nga sa inyo, pwede yang gumalaw, may potential yang gumalaw. Ibig sabihin, it has a potential energy. May energy yan, hindi nga lang gumagalaw. Pag gumalaw yan, it is now converted to kinetic energy. Okay? So, potential energy, mgh, kinetic energy, 1/2 mv square. And this one naman is the energy in the molecules, no? When the molecules vibrate, no? That's called the vibrational energy. Vibrational energy. Ito naman yung ginagawa sa microwave oven nyo. Okay? Nag-microwave ka ng ng pagkain, umiinit, 'di ba? Bakit? Kasi yung molecules mo doon, pinapagalaw mo, no? And then when the molecules vibrate, according to kinetic molecular theory, pag gumalaw-galaw sila, umiinit, no? Na-discuss sa Gen Chem yung kinetic molecular theory, so you should be familiar with that, okay? So pag gumagalaw-galaw yung mga molecules mo, umiinit siya, okay? So vibrational energy 'yan. Solar energy, ayan. Yung sunlight, tatama dyan. May energy yon, nagiging kuryente yan. Nuclear energy, okay? So ito yung nuclear core. Okay, so pag nag-split yung mga atoms dyan, may energy involved doon. Okay. Ito, chemical energy to. Kapag sinunog mo yung kahoy or yung posporo, maglalabas siya ng heat, no, which is a form of energy. Okay? So yun. In this subject, no, we are going to talk about chemical reactions and their energy. Okay? And this field of science is called the thermochemistry. So ito yung gagawin natin for the rest of the April until May. Okay? So may timer na tayo, 5 minutes na lang. Tutuloy pa naman natin to next meeting, don't worry. Okay? So yan, ini-introhan ko lang para alam nyo na yung di-discuss ko next meeting. Okay? So in this subject of thermochemistry, ayun, gagawin natin is that we will deal with how much energy can we get from a chemical reaction. Kaya ba natin i-compute? Kaya. Nagawa na nga natin kanina. Ibig sabihin, we can continue doing that, no, to determine how much energy can be obtained from our materials. No? Okay? So yun yung focus ng thermodynamics. No? So, yun lang. So, yung iba, next meeting ko na lang itutuloy. No? So, mas maganda to pag tinuloy-tuloy na yun. No? Anyway, so these are some of the reminders. So, on Wednesday, we will continue our introduction together with the first law of thermodynamics, internal energy, work, and heat. No? So, discuss natin yung Tatlong yan next Wednesday. And then on Saturday, we will talk about enthalpy and Hess's law. Reminders, yung mga group assignments ko, isasubmit pa yan by May 8. So marami pa kayong time to answer that. Pero ayun, wag kayo gagawa sa araw ng pasahan. Okay, kawawa kayo. Okay. So, matagal naman ako mag-deadline, no? Always advance yung aking announcement naman. Okay, so you have more time to study and to review. And after the submission, ibibigay ko yung answer key. Okay? Kasi yung quiz natin is patterned sa mga group activities natin. Okay, so kung ano-ano yung mga pinagawa kong group activities sa inyo, ganun yung magiging quiz natin. Ha? Okay, so keep that in mind. Only leaders will submit, no? So, siyempre, may format na ako na nilagay sa Google Classroom. Okay, just download the file. Nilagay ko na yung format doon. May groupings na naman kayo. Mag-usap-usap na lang kayo dito sa MS Teams. Okay. Pwede sa MS Teams, pwede naman sa Messenger, kayo bahala. Although ginawa ko yung MS Teams kasi there will be times na group yung ating recitation naman. No? Pag group recitation, pag tumama yung group nyo, lahat kayo may points, no? Okay, so ganun yung pwede mangyari sa atin. Okay, so nilagay ko na sa Google Classroom yung yung ating ito. Yung format ng quiz. So pwede na kayo mag-start ngayon actually. O yung group recitation, siguro mga next meeting, ayan, makapag-start tayo. Okay, so ano yan? So ito yung format, palitan nyo na lang yan, diploma in something, coverage, yan na talaga yan. And then the group, okay? Group leader, kayo na bahala, no? Ayan. Then ito yung questions, kakopy nyo na lang yung questions na nilagay ko sa PowerPoint, kailan naka-bold face, no? Then yung solution nyo ay, ito type nyo. May sinulat ako dito. Kailangan yung equation nyo ay naka-align at the equal sign, okay? Kailan naka-align siya sa equal sign. Pakita ko sa inyo. And dinerive ko dito yung quadratic formula. Okay. Kasi yung problem dyan, derive the ganito ganyan. Okay. Ano to, naglalag. Ayan. Ayan. Kailangan yung equations nyo ay naka-align at the equal sign. Paano ginagawa yan? Kailangan dikit-dikit yung equations mo. Sunod-sunod siya. Then you highlight them. Okay, you highlight the equation, then you right-click, align at equal sign. Yan. Okay, so para malinis tignan. Then you highlight your final answer. So, ganun lang gagawin nyo. So, groupings to. So, wag iasa sa isang tao. Kasi magagalit yon. Makikita nyo na lang, binabash na kayo niyan sa Facebook or sa Twitter. No? Kaya magtulungan, okay? So that will be our session for today. Sensya na, ang daming nangyari, no? Yes. Pero review lang naman kasi yung ginawa natin, no? Review lang yon, so I believe alam nyo na yon, no? But still, I need to go through those topics pa rin para walang sisihan. Okay? Kasi kailangan ma-review talaga kayo doon. Okay? So yan. So it's already time. So thank you for attending the session, no? So I hope na you will be safe.